Alright, should be making a video, I think. Something like that anyway. And we'll see if it shows up. And I'll do a little bit of this, whatever, pop out chat crap and some other mush. And then I'll start the video. Yeah, alright. So right about now I'll start it, I guess. So anyway, so this is a draftphysics.com, debatephysics.com also video presentation. And unfortunately, there's just not much debate. There's not much to evidence to argue. There's just not much. It just keeps going on in this futile kind of pointless way. But there's not much I can do about that until we can provoke physics to actually do some experiments, like sliding across thin ice. So, you know, you should understand that physics basically says you can't do it. You can't slide quickly over thin ice and not fall through. You have to fall through because you can't change how much gravitational pressure you're putting on the ice, because gravity doesn't have anything to do with time. Yeah, it's really that bad. Their physics is so dumb and so foolish and so silly and so idiotic, and yet I have to keep making these videos pointing that out. Now I'm going to play a video now, Veritasium. I haven't played the whole thing, but it's just full of lies. He can't say anything in this video about the subject and actually honestly describe the real circumstance. It's just all lies. They're lies. They're not, you know, it's lies. I mean, when you're taking complete sentences out of a quote, that's lying. All right, that's not some benign, oh, I didn't quite, what's my light out for? I don't know. It doesn't really matter. That's going to help. But really, garbage video. So, I think I have this arranged where I can see what I need to see and get away with what I have to get away with and play the video. So, leave us play the video.
In 1935, Einstein came up with a thought experiment that showed quantum mechanics breaks one of the most sacred principles in physics, that nothing can go faster than the speed of light.
Alright, so this is just, to me, kind of an idiotic thing. Just this whole going faster than the fastest thing that we could know of in the universe. And it just comes down to, well, of course you can't go faster, because how could you go faster than the thing that's pushing stuff around? We know the forces are what's pushing everything around. How could you go faster than the forces pushing? That's like I give you, you know, you run, and then I give you 10 pounds to carry, and then ask you to run the same race, and you're not gonna, you know, you're not gonna run as fast because you're 10 pounds heavier. Duh. I mean, you could never push something and go faster pushing it. Why would that even be? You know, we don't need Einstein to show up to figure that out. That's what that would be my first argument is. We don't need Einstein to tell us that. It looks like Veritasium's getting all butchy. It's a Schwarzenegger now. He's a Schwarzenegger.
Physicists assumed he was wrong. They thought that at 56, Einstein was an old man past his prime.
So, all of this stuff, right? I mean, obviously, yes, Einstein didn't go with the fairy loop-de-doo girly physics. And you know, but his own theory was spooky action. So his own bent space crap was the same kind of nonsense of you know, just overtly magical. I mean, no point in calling something else spooky action when you're saying a bent geodesic makes things move. That's spooky action.
And just unable to accept the new theory of physics because it was too radical. But 30 years later, one man stumbled across Einstein's forgotten...
Oh, this silly Bell crap. So anyway, premising getting to all this stuff, they just lie and then lie and then lie about all these... all the ways we got to eventually Bell. And it's all crap about experiments that they can't, as a fact, be done. And they just claim they do these experiments, just like they claim they've seen a positron or seen a neutrino. They just claim it.
Paper when he realized something. The prediction could actually be tested.
When scientists ran the experiment, they were shocked.
So scientists didn't run the experiment. They never used the experiment as an example. So what we're going to watch them do is to create all kinds of silly things like envelopes or teddy bears or some kind of bullshit. Say, well, there's 4 teddy bears and 3, and it's not going to have anything to do with an actual physical experiment. Why wouldn't you explain your experiment by showing your experiment? Right? If you're going to say the experiment proves it, why wouldn't you just explain how the experiment works and how the experiment proves it? Oh, that's right, because the experiment is so convoluted and so wishy-washy in being able to do what they claim it's doing. That's why they don't use the actual experiment, because you won't see it in the actual experiment.
Quantum physics really does break the universal speed limit.
We're obliged to invoke something like actions going faster than light from one place to another.
Yes, whatever. We're not obliged to do any of that. And Bell didn't believe it, actually. So again, they're just kind of stealing quotes, and it's stealing quotes, just little sentences. Taking sentences out of context. Very dangerous thing to do is take sentences out of context.
This is a video about one of the spooky...
No, it's about a video about you just selling this horseshit religious crap physics, okay, where you claim that fucking electrons don't travel through wires and all kinds of other bullshit that you just made up. That's absolute garbage. It's a religion. It's Veritasium, the religion, and you're just the preaching your sermons on the mountain of bullshit.
And most misunderstood experiments in all of physics.
Oh, what a pile of crap. And completely misunderstood because of the lies you people tell about these experiments. The electron double slit experiment, well, there's no slits. They're going to bring up Stern Gerlach here. And it doesn't have anything to do with what they're claiming they're testing. Nothing. Zero.
And it might even be the strongest evidence we have that...
Right, the strongest evidence we have that they're all idiots is they think I can't slide quickly across thin ice and not fall in. They don't think that's possible. Because friction is always the same, because you always weigh the same, because gravity isn't about time. It's not about how long you're in a gravitational field. It's just like it's nothing like suntan. It doesn't have anything to do with how long you're in the sun. No, it just has to do with how much you move around.
We live in many worlds.
Oh, fuck that puke. So that's all they're selling is the wooiest bullshit. This insanely silly, made-up, wooey garbage universe made out of nothings and wooey-calls and spookles and spookums and rookums. It might as well, why don't they just use the old jargon? Why don't you just call things pixies and hobgoblins and what else is there? Yeah, that kind of stuff. Use the words you already have, because that's all this is fable. This doesn't have anything to do with reality.
If the sun were to disappear all of a sudden, how long would it take until we noticed?
All right, so we all already know the answer to this, okay? That we figured out gravity is the same force as light. It's moving the same speed as photons, so that's a huge giveaway. All of the forces, magnetism, electricity, gravity, and light, all happen to move at exactly the same speed. So maybe it's not the speed of light. Maybe it's the speed of force. Maybe that should be the way you fix the terminology. After hundreds of years of analyzing it, you figure out all the forces are doing exactly the same speed. Maybe you ought to say, hey, wait, maybe we ought to say not the speed of light, we ought to say the speed of force. And it's obviously not some sort of completely different thing. If it's moving exactly the same speed as a photon, well, then probably it's obeying the same rules. So I don't have to put gravity in the bent space or bent geodesic category. I can put it right back in the real universe and say photons are causing it. Damn. And it's so damn obvious.
And were released out into space. Newton's theory says that gravity acts instantly across any distance.
Okay, so it's not Newton's theory, so that's the big lie. Newton didn't speculate on this. All right, in Newton's time, is where they first found out there actually was a speed of light. So let's understand, Galileo did some experiments, not very conclusive. But, so in that same period that Newton existed, it became established that, yes, you have to wait for light to get to us. All right, and so they figured that out with all of their observations of distant planets. They could figure out how far away the planet was because they could figure out how far their calculations were off, and it would demonstrate how long it took the light to get to them. So they were figuring all that out. There was no conclusion that, oh, gravity must be instantaneous.
So if there's a change in gravity.
That wasn't essential to the theory at all. That wasn't what Newton was saying at all. And what Newton was saying was a time-dependent force. Newton knew that you could slide over thin ice quickly and you would weigh less because you were in less gravity. Newton knew that. These morons don't. Damn. I mean, it's just ridiculously evil to say Newton's theory was it was instantaneous. It's not his theory. And he points out the very fact that he knows it's a real mechanical thing. So they're going to pervert the quote where Newton basically is saying, if you think it's not a mechanical thing that's happening, and we just don't know what it is yet, then you're an idiot. I mean, only an idiot could think it just magically happens. Obviously, this information is transferred. There has to be a mechanism through which it's transferred. There is a force mitigator. And they're going to lie about that statement by Newton. Watch, I'm just going to show you. I will show you a huge, giant deception.
We should feel it immediately. But Newton himself was disturbed by this, that one body may...
So this is in optics, all right? And he wrote this in a letter to another guy. So just look at what they did to this fucking quote.
Act upon another at a distance is...
See those little ellipses? So he just took out a big, giant chunk. Okay, now he's going to take out another big, giant hunk.
To me, so great an absurdity that I believe no man...
More taken out. So just keep deleting his comment. Keep deleting the key information that describes what Newton is saying about gravity.
Who has a competent faculty of thinking can ever fall into it.
Right, okay, so look at what he did here. So he perverted his quote, just see all those little dots. Those little dots, they look so harmless. Oh, there's those 3 little dots. 3 little dots representing 4 fucking sentences that are gone, that are missing, that completely describe what he's actually saying. It's just so damn fucking irritating that they get away with this. I'm the only person who points out you shouldn't be lying about Isaac Newton. I mean, it's disgusting. Why am I the only person saying people shouldn't lie about Isaac Newton? I'm the only person sitting here who cares enough about science, cares enough about these subjects to say, well, come on, even if Newton was wrong, you've got to defend this fucker. You don't misquote him to make him wrong. All right, so this is the real quote. I mean, it's gigantic, okay? So all that crap that he said, that little tiny whatever, 20 words, and here's the real 50 words. It is inconceivable that inanimate brute matter should, without a mediation of something else, okay? So he's saying basically, so the matter should do something without the mediation of something else, which is not material, operate upon and affect another matter without mutual contact. So he's saying, yes, imaginary made up hobgoblin juice, well, even that would be something. That would be hobgoblin juice. But just to say it happens, that's bullshit. Now there's ellipses here too, ... So I don't know. Yeah, the moment where you go, you're getting this quote broken. Anyway, that gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum without mediation of anything else. So he's arguing right here. He's saying without mediation, without something, there's no way you could even conceive of this nonsense theory of the magical gravity. Okay, by and through which their action and force may be conveyed from one to the other. So again, he's arguing nothing isn't a good answer. Okay, saying nothing is happening is stupid. There has to be something. There has to be an ether. There has to be some mediator. All right, is to me so great an absurdity that I believe no man who has a philosophical matters, a competent faculty of thinking, can ever fall into it. Gravity must be caused by an agent acting constantly according to certain laws. But whether this agent is material or immaterial, I left to the consideration of my reader. So he's not going to tell you what it is. And by immaterial, does that mean really immaterial? Or does that mean just very discrete, very small? So I could argue that photons are material. And again, it's up to the reader to say, oh, has somebody proven otherwise? Because I don't think anybody's proven otherwise. All right. But that, huge difference between what Veritasium quotes Newton as saying and what Newton actually is arguing. Gigantic difference. I mean, they're just putting fake, phony words in Newton's mouth. So it's just as bad as when they say Newton said F equals ma, and that somehow F equals ma means gravity's a distant dependent force, when Newton overtly said, he described gravity in complete Galilean terms and pointed out like 7 times in the same paragraph that it's a time-dependent force, that time is what makes it function, that time is how it functions over time, that it applies its energy over time. It's not a distant dependent force, it's a time-dependent force. So again, it's all this lying. All right, continuing. We have a chat. Same two fellas. I do appreciate your interaction. All right, physics model of gravity is incomplete and nonsensical. Physics is. I guess you have to say conventional physics. The model proposed by conventional physics, of gravity is incomplete and nonsensical. Yes. But, I mean, you have to really say something more specific, right? I mean, you just have to point out their model basically says you can't slide across thin ice by going faster. It won't work. That's their model. All right. The interactions between force bits and matter is so numerous that it is difficult to imagine. Faster than light isn't necessary. Well, it's not about it being necessary. It's about the fact that we are aware of it. We know that when we see a supernova, right? The telescope sees it. We all know it happened, 500 million years ago, or 1 billion years ago, or 5 billion years ago. We all know that, right? So there's no confusion. We're not like, oh, gee, there's one right over there, or what happened next door, and these two are simultaneous. We're really not confused. We know the difference that, we can't know about something until the light gets to us. We have to wait to have knowledge of stuff. There's no instantaneous knowledge system. So we know, we have to wait to learn about something happening. So yes, something could happen very close, and then something could happen very far, and they happen at different times, and I'll hear them at the same time. Well, so what? We know the sound takes time to get to me. I mean, this is just ludicrous that you even have to have this conversation with intelligent people, that somehow I should be fooled, that somehow when I see it or when I hear it is when it actually happened. I mean, aren't we way past being that stupid? Or shouldn't we be way past being that stupid? That we would even indulge in any kind of conversation that somehow when we experience something is when it happened? I mean, that's as dumb as the Earth-centered solar system. I mean, that's just plain silly. Like, we make it happen because it affected us, so therefore that's when it happened, is when it affected us. I mean, it's just silly because we know this shit already. Ugh, it's just creepy.
But in 1905, Einstein realized action at a distance isn't just absurd, it leads to outright paradox.
All right, so this is the silly thing, right? When action at a distance is absurd, when fucking that's all his theory is saying, that there's action at a distance. The bent geodesical stuff makes stuff move, through the magic power of bent geodesicalness. I mean, it's not a theory. It's no mechanical device. He hasn't solved Newton's problem. How the fuck is Einstein's answer resolve the question? It doesn't provide a mechanism at all. There's no ether. There's nothing. There's no mechanism. I mean, Newton is saying, I don't know what's causing it. Einstein's saying the same thing. He's just saying, well, somehow the bent geodesic is a better answer than smicker, smacker, smacker. I mean, I could say flipper, flipper, duper. That's just as good an explanation. I mean, it's just as much knowledge in it as saying bent geodesic. That doesn't say anything. We already know it's doing the opposite of what a light bulb does. It's creating an inverse square radiating field. So what's complicated here? Lots of things do it. Everything almost does it. Every spherical object that radiates does it. So it's not that mysterious. Charges do it. You make a round charged ball, like one of those, whatever you call them, and the radiation coming off it's going to be the same, doing the same thing. Bent geodesic inverse square. Oh, anyway, just so annoying.
Einstein had discovered that observers moving at different speeds can disagree about when events happened. Let's say you see
I mean, it's just so stupid. Well, of course you're going to disagree if you're in different positions. Why wouldn't we know you're going to disagree? Of course you're going to disagree. If you're closer to one, you're going to hear it sooner. Yeah, we already know that. Not interesting. Not interesting to me.
two things happen at the same time. An observer speeding past would see it differently. To them, one of these happened first, and both points of view are equally valid.
No, it doesn't make any sense. Both point of views are equally valid when we do know the speed of these forces, so we know how to interpret them. We have the Rosetta Stone. So if it's sound, then we know how much fast the sound travels, and we can figure out the right answer. And if it's light, well, we know how fast it travels, so again, we can find out the right answer. So again, this is just such bullshit that we somehow can't figure out the right answer. We can't get it right. Yeah, sure we can. We don't have to say both perspectives are the same, are equally valid. Any statement is equally valid. Those statements aren't equally valid. One thing was actually closer to the other thing.
But in the case of gravity, this leads to disaster. Say you see the sun disappearing and Earth flying off at the same time, as Newton predicted. Then,
so again, this isn't a real thing. Newton didn't predict that. So again, it's just, again, they're just lying about what Newton said. Newton didn't know. He didn't have any facts, okay? The fact is his Newtonian mechanics, all right, hadn't been done precisely enough, because the telescopes weren't good enough and time clocks weren't good enough for him to be able to detect the tiny difference that it makes.
the other observer sees something impossible. They see the Earth flying off first, even while the sun is still there, and it should, of course, be pulling the Earth in. So to them, it looks like cause and effect are reversed. The only way out of this paradox is...
So there's no paradox, and obviously it can be understood that, yes, this whole thought experiment is bullshit, right? They should have an actual, like a sunspot or something, some kind of real event, not some magical, we're going to make gravity disappear event.
to reject the assumption we started with, so gravity can't be instant. It took Einstein...
So again, it's just garbage. That's a nonsense argument.
10 years to fix this issue, and in the process he completely overhauled our understanding of gravity.
We know gravity is the same speed as the light, and that doesn't fix it all that much, frankly. You can still be deceived just by moving the spaceship in the opposite direction. Well, anyway, I don't want to go through all the details of that geometry of that thought experiment, but the fact is, depending on which way you move the spaceship, you'll get all kinds of different answers about what happened first.
Gravity is caused by the bending of space-time. When there's a change...
So they all say so. So we have to believe this. Why? Because they say so, no other reason. And I don't even know what the fuck this... I didn't even look at this image. I don't know if you can see this. Can you see this fucking image? I mean, these lines aren't even round. I mean, it's not even a circular in any way at all. Why is it warped in this bizarre way? Why has it got it's got a kind of polarity to it? Why is it polarized? Gravity isn't polarized. Illustrative representation. See description for more details. Wait, it can't be it's not a rational representation because your gravity is polarized somehow. I mean, that's, this is little stuff, but I just mean, look, the whole stupid bent space thing is wrong, but why draw it even wronger? I mean, using a two-dimensional drawing to talk about a three-dimensional sucking, is cheating all over the place. But then to draw it this wrong way, which isn't even right. What the fuck? There's a big mountain here. What's this mountain doing here? Why are these weird bulges in the middle of your bent geodesic? I mean, Jesus, this is such crap. This is such crap physics. This science is so bad, and I can't believe 10 million people will suck this crappy video in and eat this shit. Eat this absolute shit science.
In gravity, that only affects the local space-time, and then that ripple spreads out to nearby regions, which...
So he's turning it all into flat space now, somehow. The whole thing is just garbage.
Spread farther out until eventually they reach us. This theory of gravity is local because effects spread from place to place at the speed of...
Yes, well, the point is gravity is being caused by a real speed of light mechanism, and that's the simple explanation. And yeah, okay, you don't want to really think about photons doing it. Well, photons are doing it. And there's lots of good reason to understand that photons are doing it, because the center of the Earth is fucking melted, and it's not some magical force that melted it. It's not 4 billion year old asteroid impacts that melted it. It's got to be melted constantly fueled by the pressure created by gravity, the absorption of photonic pressure, constantly.
Light instead of being instant. From our frame of reference, if the sun disappeared, that ripple would take about 8 minutes to reach us. Another observer might disagree about the length.
Yeah, another observer. Who cares? We can draw these pictures, right? This is the part I just don't understand. We can draw these maps, we can put things at the right distances, and we can see, oh yeah, this guy will see it 13 minutes later, and this guy will see it 28 minutes later. I mean, we can see all that. Why is this even a subject, that somehow this is a subject? How is this a subject? The fact that we don't see things when they happen in the big universe, I mean, motherfucking duh.
Of the delay, but now we all agree that the sun disappeared first.
This is why nothing can go faster than light. The delay between cause and effect ensures all observers agree on the order.
After Einstein fixed gravity, all of
He didn't fix anything.
classical physics obeyed this important rule. But then, Einstein studied the new theory of quantum mechanics and made a terrible discovery.
I mean, just understand, that whole sequence was just about a false premise that somebody assumed there was such things as instantaneous, and that's not what they assumed. And because of Einstein's time dilation, you could still create a circumstance where it would appear as though a dead thing was still alive, or a live thing was born, or was existing before it was born. I mean, you could actually bump into something and bump into its birth later because of this stupid argument that somehow time is about location.
is one of the most famous photographs in physics. It was taken at the 1927 Solvay conference, where the architects of the brand new quantum theory gathered to discuss it. Around 60% of the attendees would win Nobel Prizes, but Einstein thought they'd got
groupthink. So it just proves how this is what physics was for hundreds of years, is that there was 35 people who got to tell everybody what the truth was. And there really wasn't anything more than that. It was just 35 people sending letters to each other, exchanging letters saying, let's all have a vote. What idea do we like the best, and we'll support that and wave a flag for it. That's it. It wasn't really science.
something fundamentally wrong, and this was his chance to prove it. So he took to the stage with a thought experiment. Imagine you fire a single electron through a narrow slit toward a circular detection screen. Well, quantum mechanics says that this electron has some sort of wave associated with it, called a wave function, which spreads out through space as it travels. When the electron hits the screen, you detect it at a single point. Where it turns up depends on the amplitude of the wave.
So that's all basically enough, but you're just saying, why wouldn't Einstein and everybody else in the room just say, well, how can I shoot an electron through slits? I mean, the slits are automatically going to have a charge of some kind. They can't be uncharged. So aren't they going to affect the electron the closer it is to one side? If it's closer to one surface than the other surface, is it automatically going to get bent in that direction? I mean, can't I make a huge number of predictions about what will happen to that electron? And the answer is, of course you can make a huge number of predictions.
The wave is very big, and
it's not going to be anything like random. That's the simple truth. Random ain't going to be what it's doing.
Particular area, the electron is more likely to turn up there. Let's say it appears here. So far, everyone was following. This is what quantum mechanics...
And why it fell there is clearly just because of where it went into the slit. So where it goes into the slit decides where it's going to end up on the wall, and that'll be the fact anyway. And so the idea that there's no particle somewhere else, all right, now I don't know how you would detect the absence of a non-existent particle, but I guess that's part of Einstein's argument somewhere.
Predicts. But Einstein's next question surprised them. Why doesn't the electron turn up at this other spot a moment later? There's only one electron, so we can't detect it twice. But the way quantum mechanics ensures this is that when the electron was detected at the first spot, its wave function collapsed to 0 everywhere else instantly. That's why the probability of finding it at the second spot is now 0. There's no longer any wave there. But Einstein asked...
No longer. So that part you're just saying, I don't know what he's describing here. We all don't see we don't have a videotape of the conference. We just have people's notes. So who knows?
The audience to think about what this means. The measurement here must instantly affect the wave function over here, no matter how far...
Yes, it's going to affect it, but it's affecting it with the absence of a particle, not the presence of one. So, I don't know. Can you deduce anything from the absence? I don't think you can.
Apart these locations are. In other words, quantum mechanics requires instant influences across distance. It violates locality. Einstein concluded it.
So that would be a very good argument. I would argue that yes, if you made some way of these being entangled electrons. So I think his argument was there has to be an entangled electron. I don't think he was arguing for a nothing on the other side. So there had to be more to this argument because frankly the way it's presented, it's not an argument at all. I don't see it.
His talk by saying this is an entirely peculiar mechanism of action at a distance, and that this implies to my mind a contradiction with the postulate of relativity. Einstein's argument was so simple and his talk so short.
So again, it's this whole thing. Yes, if you're going to believe there's two electrons, but if there's only one electron and it only lands in one spot, how did I learn anything about any other electron? I can't learn something about some other electron. So I don't see how there was no presupposition that entanglement was involved. So if entanglement's not involved, I don't know how that argument makes any sense. But anyway.
That people didn't know what to make of it. One audience member said, I feel myself in a very difficult position because I don't understand what precisely is the point which Einstein wants to make. No doubt it is my fault.
Yes, and that's Bohr. But Bohr was wrong about everything. So, this whole Bohr model of the atom was garbage. It's not a solar system. Electrons aren't spinning all over the fucking place. All that crap is nonsense.
That man was Niels Bohr, the most influential figure in quantum physics at the time.
So I don't know why he was the most influential. I don't know why people paid any attention to him. He was basically a religious kook. So, yeah, I don't understand why people were so enthralled with Bohr's mushy contributions.
Time. Bohr's institute in Copenhagen had become the hub for the new field. Dozens of young scientists like Werner Heisenberg came to learn from him. As one of his disciples remembers, Bohr had invited a number of us to his home where we sat close.
So I guess that was the religious thing. So I guess that's it, right? They sat close to him, literally at his feet, learning, tell us the fables, Jesus. So it's just how the religion is born.
To him, some literally at his feet on the floor so as not to miss a word. Bohr wasn't the one who wrote the mathematical rules of quantum mechanics. Instead, he told everyone what they meant.
Oh, it's just so silly. He told everybody what they meant. What does that? They mean there's a God. Who are you to tell God what to do? That's his kind of rhetoric. Yuck. So obviously Schrodinger mocked Bohr's bullshit with Schrodinger's cat, and that's the funniest part, is that something that was intended to mock quantum mechanics, they flipped it, just like they flipped Newton's statement. They just flip it, try to turn it into the opposite statement, like somehow Schrodinger was saying great idea. No, he was saying stupid idea, really dumb.
While others were confused by the theory, Bohr offered answers. His philosophy became known as the Copenhagen interpretation.
Right, and it's just this mushy idea that somehow photons go through slits and forget how they don't know where they are, they don't know how where they're going, they're just superimposed crazy-atons. And they're going to interfere with themselves. They're going to pretend they went through both slits and every slit, and they went to Venus, and they went to Mars, and they went everywhere in the universe, and then they de-entangled and just went to one place after all. And they de-entangled somehow by what measurement? Oh, because we measured them. Not because the sun measured them, or not because a cosmic ray was measuring them, not because some other photon from some other location was measuring them. Only our flashes from our camera, only our measurements count. I mean, too ridiculous. Oh, it's so silly. I mean, they really thought this kind of crap, that somehow this measurement thing is actually a thing. Like, we're not getting measured all the time. And right now, every millionth of a second, there's a gigantic volume of fucking goddamn, cosmic rays, gamma rays, photons, infrared, all kinds of photons flying through you. Radio, cell phones, just in a huge number. You can't ever be entangled. There's no point where you're not having your picture taken. You're constantly being photographed, and so is your electrons and protons. Every one of them is being outed all the time.
Of quantum mechanics.
My general understanding of the Copenhagen interpretation is you have the wave function. It describes everything that you can know about particles.
So too silly. It describes stuff that you can know, right? No, it's everything you can't know. So the only way you can actually use the equation is you have to know stuff you can't know. So that's why it's never used. They never use this stupid equation to solve anything, because you can never use it, because you can never know all the stuff you have to know that you can't know. You have to know it, but you can't know it. So there's no point in doing the math, because you can't know the variable you have to put in the equation. It's bullshit, in other words.
Or a system, and it evolves according to the Schrödinger equation, and at some point you're going to make a measurement, and at that point the wave function collapses.
I think that...
So making a measurement. They keep talking about this making a measurement thing. There's no such thing as making a measurement. There's no such thing as our energy stops something from happening and all the other energy in the universe doesn't make it stop. It's just too ridiculous to think that our eyes, like that, look, Einstein again came to the rescue and made the statement, what do you think, when I stop looking at the moon, it disappears? I mean, how ridiculous is your theory? It doesn't need me to look at it to be there.
One bit of that you said was like, the wave function is all you can know about the particle.
It doesn't need me to see the photons, right? They're going to reflect off the moon whether I see them or not. Whether I have my eyelids open or my eyelids closed, the photons are going to hit my eyes. I mean, duh. I can't turn the camera off by, I'll close my eyes and now the camera will be off. No, it doesn't work that way.
And I think that was like a pretty important point to Bohr.
As Bohr would put it, it's wrong to think that the task of physics is to find out how nature is.
The job of physics is just to predict measurements in the lab.
No, it isn't. The job of physics is to model reality, to give us the blueprint, show the schematic. We want the schematic. We want to know what each little thing does, how it blink, how much energy, how many megawatts, how many this, how much. We want the blueprint. We want the schematic. We want to know the detailed mechanical model of how this motherfucker works. If I made a pocket watch in the 1800s, the guy would have a drawing of exactly all the gear work, the whole way the whole thing works. That's what physics is supposed to be. That's what science of physics is supposed to be. Is you're supposed to be dissecting, drawing a picture of all the little intricate parts, and then figuring out what all the little antennas do, and what kind of sensors there are, and what kind of smells they can detect, and what kind of chemicals they can shoot at somebody. All that shit is what you're supposed to do. You're supposed to be diagramming all of those mechanisms, and you're not doing any of that. You're just making up hobgoblin stories. You're not even close to being scientist. You don't even have the clue of what scientist is. To say, give me a good answer. Don't give me a shitty answer. Science is about getting better things than shitty answers. Don't give me a shitty answer. That's what science is.
Which quantum mechanics does incredibly well. As for what...
it's just so bullshit, this promise that it does all of this shit well. It doesn't do any of it well. There's no evidence it solves any real problem in the history of mankind. It's never cured a disease. It's never floated a boat. It hasn't recharged a cell phone. It's all a pile of crap.
What the electron is doing when you're not looking.
Right, too ridiculous, right? Why would we even have a conversation about looking or not looking at an electron? There's no way to detect one. There's no way to shoot even light at one. The polarization of light is already 500 atoms across, let alone, and the electron is 1/trillionth the size of the atom. So how the fuck could we even shoot a photon at an electron and see the electron? No, not even possible. So just how ridiculous are you going to make this nonsense, right? So electrons clearly interact with pieces of a photon, not the whole photon. Just the little bits that make up the frequency. You know, I mean, all this is so obvious. I mean, do I really have to explain that you cannot possibly move an electron and create a whole photon? Not possible.
Well, to Bohr, that question didn't even make sense to ask. The wave function tells you everything physics can or should tell you.
Right, so it tells you nothing. So again, the big bullshit is squiggly line, squiggly line, squiggly line, squiggly line, and nothing. There's no actual equation that they actually solve and actually describe anything. So unless you give them the complete blueprint of the roulette wheel, the exact velocity of the ball, every single detail, they can't predict anything any better than you can. They've got no power you don't have. That equation gives you no power whatsoever.
Einstein couldn't stand the Copenhagen interpretation. In a letter to his ally Schrödinger, he called it a tranquilizing philosophy, or religion.
Yeah, you ought to call it complete bullshit. Let's figure out how to get Bohr to step on some banana peels. He's a big fat fucker. You know, we can get him to fall down a staircase. He's just the enemy of reason and physics. Like I said, everything that got broken about physics got broken by Bohr. Bohr is the origin of all this. Well, like I said, Einstein and Bohr. Einstein's relativity is just as bad as Bohr's quantum mechanics. They're both wooey theories of bullshit. They're both non-physical explanations.
Einstein felt his thought experiment
They're not physics.
exposed a critical weakness in the Copenhagen interpretation. He'd shown that the way the wave function collapses is non-local, and so he reasoned maybe the wave function is the problem. Maybe it's not the best way to describe the electron after all.
It doesn't describe an electron at all, because obviously an electron isn't fucking waving anyway. I mean, it's just so stupid, this Diracian bullshit that they've all accepted, that somehow these hard charges are waves. They're not waves, they're charges, they're real things. Protons and electrons are real objects. They're not wavicles.
He may not have convinced Bohr of this during his talk, but he was determined to do it during the rest of the conference.
Physicists tell a version of this story.
Alright, so yeah, everybody tells a version of the story, and so do you, Bubba. They're just annoying. Oh, I have the real story, though. Their stories are just story-y. My story is story-y. Yeah, I have the real story-y. Fuck you.
You know, that you will find in physics textbooks. And
Oh, good. You won't find it anywhere. Where will you find it? Well, that would be the thing, right? You could probably find it in the actual letters that people actually wrote, but they don't show us that unless they put a bunch of those little ellipses in there, you know, to hide all the relevant parts.
in pop science books, and that, you know, physicists tell amongst ourselves that what happened was Einstein and Bohr had a great debate.
And apparently Bohr's answers got sillier and sillier, and that's the truth of it. And his last response was so fucking silly, nobody even noticed it was, you know, he had the pages mixed up in a book. So, I mean, you know, lots of explanations here saying, yeah, this has gotten so convoluted and complicated, nobody could follow along.
And Einstein was unhappy with quantum mechanics because it was fundamentally probabilistic.
No, it's entanglement, spooky action entanglement is a huge step. It's a gigantic leap in saying this is what you have to accept as part of this mechanical universe we've described. So you went from all this Newtonian mechanics to, I mean, and, you know, and Descartes and Galileo, everything is looking clockworky. Everything, even Leibniz said that. Everything's looking mechanical. And all of a sudden now you're going to throw in this wooey fucking angels and pixies into the story. I mean, fuck you. Yeah, that's really irritating. for no good reason. I'm just saying, there's no real good reason to play with this pixie theory.
He tried to show that there were conceivable experiments that you could use to get around those uncertainty relations. And Bohr showed over and over and over again that you couldn't do that. And
Okay, so Bohr didn't show any of that, so that's the big lie. Lie.
And eventually, everybody agreed with Bohr.
Yeah, and you're going to point out for the wrong reasons. So again, just more bullshit. So he's just selling this asshole's book. Can't do better for a cover. What is real? And it's all got a bunch of this wavy shit all over it. The unfinished quest for the meaning of quantum physics. No, it has to have a meaning. Ooh. It's not supposed to be just a description of the function of material objects in the universe. No, it's going to tell us what the meaning of it is. Fuck you, Adam.
That's Adam Becker, author of What is Real, a great book about the history of
Says you.
quantum mechanics. As he explained to us, Bohr may have just misunderstood the purpose of Einstein's thought experiments.
It wouldn't matter. So he's even going to concede that Bohr didn't describe Einstein's experiments right. So what the hell was the point of having thought experiments if the other guy can't pay attention? I've had the same problem. I mean, you can talk and you can draw stuff, but, people just don't get what you're saying. I think the thin ice argument, though, is pretty fucking obvious, right? So let's just make sure we write this one down again. Okay, this is their physics, right? These brilliant physics people, these Veritasium morons, they can't figure out that if I roll something across ice and it's going fast, and so its velocity line is going to look something like this. It's going to start off fast, and then it's going to, well, you can't see that, but all right, it's going to start off fast and go slower and slower. That the fact is that when it's going fast, it's not going to crash through the ice. But as soon as it starts getting, going slower and slower, especially the last 1/4 of the trip, it'll be going half as fast. So the half as fast is here. Okay, 3/4 of the way down the track, and now it falls through the ice. This is where it falls through the ice. Well, why would that be? Why would there be more friction when it's colder? Slower. Why would, oh no, it's not about more friction per se. It's not more rubbing. It's that the damn thing weighs more per inch now. Because gravity is a time-dependent force. And you're not zooming across it. So you're now heavier per inch on the surface. They don't believe that's true. Their fucking idiotic physics says that doesn't happen. Because they think it's a distance-dependent force. Morons.
We have documented evidence of this in at least one case. Einstein described a thought experiment that involved a box of photons and a mirror.
Okay, so yes, and yeah, Bohr left out the mirror. Hilarious. So anyway, but we know Einstein's stupid mirror trick, right? The stupid mirror where you go across the spaceship with the photon, and somehow, because you moved the spaceship and you moved the mirror, that somehow it looks like the photon bent. Well, it only looks that way because you moved the target. The photon didn't actually bend. It went straight across. It took the same amount of time to get to the other side. It didn't travel a longer path. None of that shit happened. It got to the other side the same exact amount of time. I mean, how did they get away with fooling people with this kind of nonsense? All right, anyway, so let me read some of this. I have no words, just can't believe the state of physics. Their diagram of space-time is crap. This is the same with their notion that photons wave. Yes, that's for sure. Double slit doesn't demonstrate photons wave. Well, obviously I've already proven that, I think. I mean, kind of decisively, that the math that works the most perfect is math that acknowledges the surfaces as the point sources. That's where you draw all your vectors from, is the surfaces. Thin ice argument is easy to understand. It amazes me how people don't get it. Yes, it is. Well, the lever is so easy to understand. How could you possibly not conserve momentum? How can you believe levers don't conserve momentum? I mean, it's so fucking stupid. Science presenters seem more interested in telling stories to make things exciting and less interested in collecting facts to draw logical conclusions. No, it's more evil than that. This Veritasium motherfucking little weaselly cunt is proposing like he's a great scientist. He's innovating. He's creating new science for all of us to believe. He's proven that electrons don't travel through wires, that's not how electricity works. He proved it. You know, this is the kind of horseshit they're pulling. Steve Mould did his retarded video, and he basically made the claim that levers don't conserve momentum. Okay, he didn't prove it. He didn't do any experiment, but he's saying, what other logical conclusion can you possibly have? Leibniz said so, so it must be true. Isn't that a good enough argument? Leibniz says so. But that's all they got. I mean, this is evil. These people aren't, you know, science present. They think they're scientists. They think they're doing science. What am I supposed to hit here? Yeah, I'm having a nicotine moment. Where am I? I need a cigarette.
Its purpose was to show the non-locality of the Copenhagen interpretation in action.
Bohr just misunderstood it. And when he recounted it to others later on, he drew a little diagram of what Einstein's thought experiment setup was, and it just didn't have the mirror in it at all. And yet this is taken as like the great victory for Bohr over Einstein, which is crazy.
Oh yeah, so he's pointing out it's crazy that Bohr won the argument because Bohr's argument was so fucking bad. So it wasn't about the physics, it wasn't about the science, it was about the religion. This was just a funner religion. The shark god is a lot cooler than the pixie shrimp god. So some people, oh yeah, no, the pixie shrimp is the real thing. It's the real god. And yeah, everybody's like, oh, I don't want to have a shrimp as a fucking god. I want a shark as a god. I want something powerful. You know, they didn't want the, oh, God is an earthworm. No, that's not cool enough.
History is written by the victors, right?
Yeah, so it's all a big joke. Science is written by the propagandists. Whoever had the best, I had the best drawings, the best animation, so I win. My science wins, because I animated it the best. What a pile of crap. I just can't, I'm just amazed that this doesn't piss anybody else off. This patronizing, fucking distorted lies. Now the big one's coming. The big monster lies coming.
To understand what Einstein was arguing for, think of the relationship between Newton's gravity and general relativity. Newton's theory works well in most situations, but in that theory, gravity is a non-local force.
So again, it's just more bullshit that it's a non-local force. It's just such a lie. There's nothing, and the difference really is that Newton believed in gravity being a time-dependent force, which you don't even understand. You somehow think that, well, if a meteor comes into the sun, it's going to go faster and faster because of the gravity, because it travels this distance. Well, no, if it travels that distance in 1/1,000,000 of a second, it's not going to get that distance worth of gravity. It's not going to get that added. It's only going to get 1/1,000,000th of a second worth, which is, 0.00000000001 Newton. So, you people are just so fucking stupid. You're so ignorant.
Leading to
Talking
paradoxes.
this shit.
This was the motivation for coming up with Einstein's general relativity, which is local. Einstein believed this.
So just so dumb to say gravity isn't local. I mean, what the fuck you're talking about? It's right here in front of me right now. How the fuck could it not be local? What the fuck? Too silly.
Same logic applied to quantum mechanics. His thought experiment revealed that quantum theory is non-local, so just like with Newton's gravity, quantum mechanics must not be the final theory. There must be a local one that will replace it. And as a bonus, he thought...
So obviously that's a good reasonable thought in the sense of just saying, no, you got to be able to make this all fit together. And so if there's particles making stuff happen over here, there's got to be particles making stuff happen over here, and vice versa.
This new theory might even unify gravity with the quantum world.
It would be hard to imagine coming to the final theory right away, and the fact that you can see paradoxes like this would make you think.
So these aren't paradoxes. This is a completely fake paradox based on a perceptual thought experiment theory that didn't have anything to do with Newton or any reasonable theory of gravity.
There's got to be more to it that we just don't have yet.
But Einstein hadn't even persuaded Bohr that quantum mechanics really is non-local. So in 1935, he made one last attempt to convince the community that there was a contradiction.
So there wasn't one last attempt, because after that was Schrodinger's cat. That was another attempt.
Between quantum mechanics and relativity. With the help of two younger colleagues, Boris Podolsky and Nathan Rosen, he formulated another, even more striking thought experiment that shows the non-locality of quantum mechanics. This paper is now known as...
And in this paper, absolutely none of the crap he's going to say this paper argued actually happened. This paper had no positrons in it. There was none of that Diracian crap was in it. It didn't have anything to do with antimatter or any of that crap. I mean, it's just such a fucking lie for him to sit there and say that this paper described spin or any of that shit. It didn't. All right. All it said was that the two entangled objects have some property which is entangled.
As the EPR paper after its authors. Here is a simplified version of their thought experiment.
Okay, based on David Bohm, right? So this is just completely fuck what Einstein actually wrote, fuck the whole paper, and let's just do the Bohmian theory of pushing, with the guy who's really arguing for a pilot wave theory. So this isn't Einstein's experiment. This isn't Einstein's thought experiment.
Imagine a single high-energy photon suddenly becomes two particles.
Right, so this is just the big bullshit that somehow they make photons out of, they make matter, electrons and protons, these indestructible things. These things are supposed to be eternal. They make them out of photons. This is this half-baked weirdo theory that just poofed out of nowhere. They never said this when I was a kid. All right, when I went to school, nobody said you could make photons with you could make fucking electrons and positrons with a fucking goddamn photon. Nobody said that. This is just such bullshit.
One of them is an electron, and to conserve total charge, the other is a positron.
Which there isn't any such thing. So this isn't, again, this is not Einstein's thought experiment. So that they just pretended they're going to talk about what Einstein argued, and this isn't Einstein's argument.
Since one is negative and the other is positive, they cancel out. But both electrons and positrons have a property called spin. And like
so again, there's no spin in Einstein's paper. No spin.
Electric charge, this also needs to be conserved. If the light started out...
Certainly no argument that anything called a spin needs to be conserved, right? Nobody proved that either. I mean, all this is just such crap. They're just making this shit up.
With zero spin, well then the two particles together must have zero total spin as well. For example, if the direction of the electron spin is this, the positron has to have spin in the opposite direction, so that they perfectly cancel out.
Right. So where is this positron? What's it doing right now? How exactly do these positrons, whatever the hell they are, how do they actually hang around somewhere? What do they do? I mean, it's just ridiculous theory. There's no role to play. There's no place for these things to hang out. There's no safe place to put a positron. Wherever you put one, it's going to it's going to destroy the function of the atom. It's going to break it. It's a poison pill pile of nonsense. There's no such thing as antimatter. Oh, it's just so bad. Ugh.
But the electron spin could have been this instead, or this.
Says you. There's no such thing as an electron spinning.
All of these possibilities...
There's no property. Electrons are all the same. They don't ever have a property. They just are moving or not moving. That's it. They're being pushed somewhere or they're not being pushed somewhere. But that's the only property they have. They don't have any other property. Movement is their only property.
These are valid, so the rules of quantum mechanics say that the electron does all of these possible things at once until it's measured. It's not just that we...
So again, till it's measured. It's measured right now. Every single electron in the universe right now is being measured all the time. It's being constantly bombarded by speed of light force, cell phones, photons, heat, all kinds of pressure being applied. By this discrete stuff we call force. Stuff moving the speed of force. And it's constantly taking pictures of every electron. It's telling it where to go, for fuck's sake. The electron is completely obedient to the force pushing it. Push a verse. Push a verse. Push a verse. I hit the wrong button.
In 1935, Einstein came up with a thought.
Sort of old allies of Einstein's who were very happy.
Video sponsor, you can have your
Oh,
own.
fuck you.
And now, when the
Fuck
electron
you.
is
Fuck you.
conference talk, but
So this Stern
Oh,
Gerlach
fuck
machine.
you. Yeah, this gets really wacky.
And yeah, and the fact that you can see paradoxes like this would make you.
Here we go.
Here is all of these possibilities are
There we
valid.
go.
So the rules of quantum mechanics say that the electron does all of these possible things at once until it's measured. It's not just that we don't know what the spin is, the electron really is doing everything.
So again, you know, this whole idea that these essential qualities it has. So this is a property the electron has, its spin. And somehow it doesn't matter what its actual spin is. It won't change anything about its character, no matter what its actual spin is, until somehow you crash it into something. Then it's going to matter. But it's just such bullshit. Because you know if something had a property, it's going to matter.
Only restriction is whatever the electron is doing, the positron must do the exact opposite. This also means that when the electron is measured and its state is determined,
All right, so there's no way we know. You can't measure any of this. So why don't they use the actual experiment what they actually measure? So then we could actually understand this, right? Because they don't actually measure an electron and a positron. They don't actually do this. So why are they illustrating it with one experiment and the actual experiment doesn't really have a goddamn fucking thing to do with this fucking illustration? Why would that be honest, right? I mean, again, it's just as dishonest as them showing an electron going through a double slit experiment when the electron doesn't go through slits. You know, it bangs into a crystal. So why show it one way and then do the experiment in a completely different way? That's not honest.
so is the positrons. This is what we mean by entanglement. The two particle states depend on each other. But
Right, so this is this, and again, this is just so, you know, the right-hand glove, the left-hand glove, it was decided when you put the photon into the crystal and made two new photons. You didn't make a positron and an electron. That's how the actual experiment's done. They create new photons that are not only polarized, okay, but they're a new frequency, coming out at new angles, right? And they call them entangled somehow. Well, obviously they're entangled in the sense they were both created by the same event. So of course they carry whatever that event has as a property. So you could argue that if the event was this, you know, forward back, you know, one of the photons was on the backstroke, one of the photons was on the forward stroke. That, yeah, obviously they have opposite properties. They're 100 degrees out of phase, you know, 90 degrees out of phase. That kind of thing. So this isn't, you know, they're trying to make this into something it's not. So you're using this stupid spin example when the experiments actually use polarization of photons. So again, it's just such a distortion. I mean, they're just such, you should be able to call that lying. To show this, that you're going to measure this shit, when you're not going to measure this shit in the experiment, is just plain deceptive. No, it's just fucking lying. All right. So, let me see if there's any comments. All right. Some science presenters seem more interested in telling stories and making things exciting and less interested in collecting facts to draw logical conclusions. What would be causing the spin of an electron? Well, what the fuck would the spin be? I mean, it doesn't even mean that, you know, the electron has a little face like a moon. The man on the moon, you know, the electrons have faces and their faces spin. I mean, what the fuck would their spin be? See, they think that an electron is somehow a dipole. They think the electron can create a magnetic field, you know, by oscillating, that somehow it has a positive side and it can flip it around or something. I mean, it doesn't make any sense. Electrons are a negatively charged particle. They don't have a dipole. They don't have a dipole moment. They're not dipoles. All right, they are arguing that the spin is caused by force, you think? They are arguing that the spin is caused by force, you think? No, the spin is something they've already got. It's some property they already have. So they were, through some interaction, they were rotated. So it's like a wheel moving on a car. So the car is moving and the wheel is rotating. So they're somehow saying that it has this extra energy in its spin component. Spin is a variable that is unbelievable. Well, I'm just saying they can't draw it. So I'm just saying they'll concede that, well, it's not as simple as this rotating thing. No, that's not exactly right. Because to do this, they're saying it has a polarizing moment. That is, that arrow pointing in a direction means it's polarized. How can a negative charge that's a monopole be polarized? I mean, you see how they violate their own physics? You know, I mean, now the north side of the magnet is a dipole. You know, it has a dipole moment. I mean, it's just, you know, it's just cheating. Anyway, let's get to how they lie about the Stern-Gerlach experiment.
How do we measure the particles and force them to do one thing? Well, for that, we use the Stern-Gerlach machine. It's
all right, so this is such a lie. So we know Stern-Gerlach isn't, you know, he just said particles. So it's like all particles are the same. So we were working with electrons and positrons. Now we're going to actually be shooting whole atoms, whole gigantic atoms, ions, frankly, because we're going to heat something and break pieces off of it and shoot them across by the energy of the heat we're creating. So you're going to heat the cesium, shoot the atoms off the surface. So some of them are going to be positively charged ions and some are going to be negatively charged ions. And the cesium atoms themselves are already, when they're single atoms, they're already polarized.
Essentially a strangely shaped magnet. That's how we measure spin. The orientation of the
most all single atoms of any substance are polarly magnetic. That is, they have a magneticness. They'll line up to a magnet. And it's just that they don't make strong magnets because when the atoms are all together, all the poles are pointing in different directions. So it's only materials like iron that easily line up all the nucleuses that are able to become magnets. But all the other elements are magnetic. They just can't make magnets. The atoms are magnetic, but the individual atoms are magnetic, but they're all their domains are all pointed in different directions, so they can't become magnet. So here, well, let's reintroduce it.
We measure the particles and force them to do one thing. Well, for that, we use the Stern-Gerlach machine. It's essentially a strangely shaped magnet, and it's how we measure spin. So
again, how we measure spin. There's no spin involved. There's no possibility of measuring anything called a spin. It's silver atoms being shot through an inconsistent magnetic field, okay, that will push things in directions. And the fact is, it's going to shoot the atoms at different speeds. So some of the atoms are going to fly off very fast. Some of the atoms are going to fly off very slowly. So they have completely different speeds, and then the atoms themselves are going to come off. Some of them are going to be north-south this way, and some of them are going to be north-south the opposite way, or this way. And then you're going to put them through this magnetic field. So you're basically shooting magnets through a magnetic field, and you're shooting them in this random order. And obviously the ones that are very fast this way, the ones going very fast through the magnetic field, just like gravity, if they're not in the gravity very long, they can't get pushed by it. Well, just the same is true for that magnetic field. If I go through that magnetic field really quickly, right? I mean, here's the coil. I go through it really quickly. I won't turn. I won't bend. I won't do shit. But if I go through slowly, then I get turned, I get bent, I do all that crap. So clearly that's all that's happening in this experiment. So if you actually watch the real experiment done in the 50s, there's some pretty good videos of it. You'll see that, you know, it's just showing you that basically you're just filtering, okay, as you filter how narrow the beam is and, you know, what you're collecting, that you're basically just saying that I can show the circumstance where if I increase the magnetic field, I create more polarity. That is, I move a lot more stuff further away from each other. And so you can just you're just demonstrating, though, that the simple explanation for all of it is you're sending the little magnets in all kinds of different configurations and different speeds. So you have two huge variables. You have the speed of the magnet, and then you have which way the magnet was
pointing. Orientation of the magnets determines what axis you're measuring this.
Right. So which way the magnet was pointing depends on how much it has to flip. So it has to flip 180 degrees. That's a huge amount of work it has to do. So it has to be in the field a long time to flip 180 degrees. But if it only has to flip 20 degrees, that's real doable. And then it's going to bend based on the magnetic field. So that's all that's happening in this experiment. There's nothing else you need to understand. It's that there's nothing more complicated than you have two variables. You have the speed of the atom, and then you have its orientation when it left, which is generally speaking random.
Spin in. For example, if the machine is like this, and we shoot in a particle with spin in the positive z direction, it will certainly...
So positive z direction. So again, there's no positive z direction. These are whole atoms. Again, there's not even electrons in this experiment because they're not putting a voltage across it. So there's no voltage, to suck electrons into the game. It's just heat. So that's all they have to push the atoms is heat. So they heat it, and the atoms bake. They get baked off of the surface, and they fly off the surface because of the heat. And so there's nothing else in here but those ions, positive and negative cesium ions. That's it.
go to this spot we'll call plus. If instead a particle has negative z spin, it will certainly go down to minus. So this Stern-Gerlach machine measures spin in the z-axis.
No, it doesn't measure anything.
So what happens when we put in one of our entangled particles? When the electron goes into this machine, it either goes to...
So there's no electron machine to do this. This machine doesn't exist. This is just, why is he describing something that doesn't exist? Because it doesn't exist. Now he could say a negative ion. So if a negative ion of cesium goes into the machine, it's going to go in this direction. If a positive ion of cesium goes in, it's going in the other direction. He could have been honest and said that.
Plus or to minus with 50-50 probability. Let's say our electron goes to plus. Well, this means it went from being in an indeterminate state to positive z spin. But what about the positron? Well, the only way to conserve spin is if it's now in the negative z spin state. When it's measured, there is a 100% chance it's minus. It has to be that way to conserve...
So again, they have no experiment verifying any of this. This is just made up.
...spin. But the authors of the paper realized there's something very odd about...
The authors of what paper? So again, this is whose paper? There's no paper doing this. So it says here, flipped polarity for positron for simplicity. No, flipped polarity for position... No, that says positron. For simplicity. See disk. Disk? See disk? Flipped polarity for positron for simplicity. What the fuck is that mean? Anyway, this didn't happen. This is not a real experiment. So again, why are they describing this phenomenon by using a completely contrived and fake experiment? Why can't they show it with a real experiment?
This result.
To see what's wrong with this, let's imagine that the electron and the positron carry these envelopes with them. These envelopes represent...
So this is just all this... Again, why aren't they showing us the real experiment? Why do they have to do this? Why are they doing this instead of just explaining the real experiment?
...represent the state of the two particles. Until they're measured, both of the particles are in a superposition of being plus and minus at the same time.
Right, and you have no evidence of that being true at all.
So both options are in the envelope. But now let's move the positron to someone who's far, far away. In this analogy, opening the envelope is like measuring the spin of the electron. But that causes the...
They actually were in the same room in some other part of this video, so why did they even do that fake through the, They should have just made a joke of being in the chair and just handed it to each other.
Wave function of the electron to collapse to just one possibility. In this case, it's plus. But what happens to the other envelope far away? Well, it needs to instantly collapse to...
So we know this is just so boring, right? That, oh yeah, it's going to be the opposite. Yes, magical.
Minus, because otherwise, when the experimenter opens their envelope, they have a chance of seeing plus, which would violate the conservation of spin.
And who says there is a conservation of spin? Nobody. That's right. Nobody proved that one.
If it needs to collapse instantly when the electron is measured, then...
So again, they're never going to measure electrons. They're never going to measure any of this stuff. They do an experiment with polarized light and light in different phases. So none of this has anything to do with the actual experiment. Why are they doing that? Why are they explaining it in a way that doesn't have anything to do with the real experiment?
How does it know what to collapse to? It must receive intel from the faraway electron, but that message has to travel much faster than the speed of light to get to the positron in time.
And how would you know? And how do you know? When have you ever done this over any distance at all? So all this is just made up, right? You hear these stories that they've done it. But they're stories just like they've done fusion, just like they're done doing this or done that. Those are just fucking stories. I mean, you can believe that crap if you want, but that's just crap. They're never going to show you these supercomputers. They're never going to show you this fucking qubit crap. None of this crap. And they're never going to show you this encrypted, super entangled, bullshitty stuff that they claim they did. We're never going to see any of it. Because it didn't happen.
And so with this argument, Einstein, Podolsky, and Rosen had shown that the Copenhagen interpretation of quantum mechanics really is non-local. Einstein had already shown this in his conference talk, but this...
I don't know how he showed it in the conference talk, because he didn't describe any property as far as I could tell from the argument, but he must have described some other property. He must have said there were two particles. Because how does the absence of a particle prove the... How can you prove anything from the absence?
This argument was even more decisive.
It does seem like it's the same thing, but now it's ramped up and you've got these two separate particles to do those two separate measurements, and one measurement influencing the other measurement definitely feels wrong.
Yeah.
So he's gotten all butchy, but he's getting kind of girly in his little mannerisms. Girly man.
Exactly. I think he really realized that it's measurements that are the problem in quantum mechanics.
The wave function of a single particle...
Oh, it just sucks how all of these physics communicators are all pally-wally with each other. All these YouTube empires, sucking money. Disgusting. I took out his commercials, except for the ones that he forces you to watch.
or of this pair of particles can end up spread over vast distances. That isn't itself an issue. But when the wave function collapses, the information about that...
The wave function magically collapses. They traveled billions and billions of light years and didn't encounter a single photon to collapse them. No piece of speed of light, impulse energy of any kind interacted with them through their whole trip. They were completely free of interacting with anything in the universe at all for billions of light years. Fuck you. Too silly, right? That's too silly, right? Too silly? Come on, you don't believe that, do you?
collapse needs to spread everywhere the wave function is. That's what makes quantum mechanics non-local.
The EPR paper didn't just point out this non-locality issue. They proved that there is only one local alternative theory for explaining this.
Oh, so again, this is all... I hate the way they do this jargon. There can only be one local alternative theory. No, there could be a ton of extra arguments about what the variable could be. So there could be a ton of variable theories. Theories that point out you have a variable involved. Like pointing out the fact that, well, the particles have to travel through the universe, and the universe is full of stuff, and they're going to hit all kinds of crap on their way, so they can't stay in fucking tangled. They have to be outed. They're not going to travel billions of light years without banging into anything. That ain't going to happen. Ugh, God. This physics is just such a religion.
Experiment. In this local story, instead of the electron choosing whether to be plus or minus when it's measured, it actually makes that choice when it's still in contact.
Duh, right. So it makes the choice when it's created. So again, when they do this experiment, let's just understand, they shoot ultraviolet photons in, and they get 2 infrared photons out. Right? And it only happens in certain circumstances through this crystal. So at a certain point, somehow the high frequency, twice the frequency, all right, turns into two impulses that have half the frequency, which makes perfect conservational sense, and that those two things with half the frequency, it would make perfect controversial, it would make perfect sense that they would have exactly opposite both polarizations and opposite polarization would be like this. So they have opposite like this, which is the same polarization, frankly. You know, one would be upside down this way, one would be upside down that way, but let's not argue that. They'd certainly be out of phase. So one of them, the two photons would be, because of this argument, that this is the motion that created them. Because they're going off at angles, it means the motion that created them had to be wham, wham. So they're out of phase with each other. And that's what they're calling spin, is the out of phase thing. So when they're talking about spin in these envelopes, the little plastic magnets, they're really talking about phase. And that's how deceptive this is. That's what they're actually going to be measuring in the real experiment, is the phase shift. They're not measuring spin.
With the positron, there's some random way that this plus and minus gets put into these two envelopes. Which is why the plus and minus are called hidden variables. And because this alternative theory assigns...
So again, and you don't need to call them hidden variables. All you have to do is call them variables. Variables in the event that causes the effect. And it's as simple as even understanding a spring shooting both ways or something. I mean, there's all kinds of variables to understand how a mechanism works. And so, yeah, there could be 100 variables. You don't need just one. There could be 50 that you're not aware of in terms of how you converted the one form of energy into the other form of energy.
Assigns these hidden variables in a local way while they're still in contact with each other, rather than over a big distance. We call this a local hidden variable theory. Now, this local hidden variable theory is going to be able to explain this experiment really simply.
Yes, and it's just an origin. It's just saying the event happened at the origin. You had a left glove, you had a right glove, you put them both in separate, and the two gloves went off, and there always been right and left gloves. So yes, you can find out what's in the other envelope by opening this one, because it's always right and left.
Let's pass away the positron. And now, when the electron is measured as a plus, it doesn't have to rush to tell the positron. The positron already knows. There is no action at a distance. This local hidden variable story is so much more sensible than the quantum one.
Right, but they go with the quantum one. So that's the part that you're just like, what the fuck? So why don't we just go with the simple explanation, the one that seems perfectly reasonable, since you have no fucking idea how that crystal works and you have no fucking idea how the photons are actually being created. Why don't you just go with the simple explanation then, you fuckheads? Oh, I hate this planet. I just hate it here.
So we're forced to accept one of two explanations for this experiment. Either non-locality, like the Copenhagen interpretation.
Who the fuck needs these still silly words, non-locality? So again, just makes it all sound like how far away something is makes a difference or anything. It doesn't make any difference. It's just idiotic. Non-locality. It doesn't mean anything. There's no such thing. Non-locality. You're just saying, well, we want to just cut it into states, or do you want to count it into counties, or do you want to cut it into towns, or do we count it into streets? I mean, do I really have to play some locality game? Is there some place where all of a sudden the rule fundamentally changes, where breathing's different air or something, or the photons hit us different, or somehow it matters? Is it really different in Pennsylvania than it is in New Jersey? Is it really different in California? Well, you know what I mean. Temperature-wise, of course, climate-wise, it makes a difference. But I just mean, if geography and distance weren't if we didn't have a geologically changed environment, I'm just saying, how could it make a difference? You're talking about the universe and empty space. It doesn't make a difference. 50 miles, 5 billion miles, same damn thing.
Interpretation of quantum mechanics, or a local hidden variable theory. Given that non-local action at a distance contradicts relativity, Einstein thought this was definitive proof that the Copenhagen interpretation of quantum mechanics is wrong, and therefore there must be some local hidden variable theory that will replace it. Einstein showed us that quantum mechanics allows influences that seem to travel faster than light. But with today's video
Oh, fuck you. I just tell you, oh, so evil. NordVPN. This is the way to become a hacker on the internet. Just get yourself one of these VPNs to hide your trail so you can do all kinds of slandering and bad things to do, and you can do all kinds of evil doing and all kinds of shit. And yeah, we'll show you how to be a good spammer on the internet. Yep. Be a good, powerful troll. Get your troll boots at NordVPN.
The EPR paper certainly got a lot of attention. Without asking Einstein, Podolsky leaked the paper to the press, and the story ended up in the New York Times.
Prodigious harvest of the day's intelligence is reaped.
Einstein was the most famous scientist in the world, and he was going after the strange but successful theory of quantum mechanics. So, of course, the
strange and successful. Again, this much they tell you about its success. There's no fucking success. There really isn't. There's nothing. There's no, except for circular experiments. That is where they built a machine that does something. You know, drop spring. Okay, and then they calculate how many times the spring bounces, and then they try to, you know, they keep doing the experiment, and they find out, well, there's irregularities. Like each time it comes out a little bit different, does different things. And so they just keep refining the machine and refining their mathematical, oh, okay, it's about the tension in the spring, but the string, you know, over time the spring gets worn. So they keep refining the two to just keep matching those two numbers. So they get a machine that's better and better at getting the same result. And they get mathematics that's better and better at getting the same result. But they're working in cahoots with each other. They never predicted anything. One didn't predict the other.
press loved it. But what did scientists think of the argument itself?
So the reaction of the physics community was at first mixed. You know, there were some people, sort of old allies of Einstein's, who were very happy with it. Schrödinger being sort of at the top of that list.
Yes. Yes.
And in fact, in an attempt to clear up some of the misunderstandings that people were having about the EPR paper,
That's right. Schrödinger really mocked the fuck out of it. Mocked the fuck out of it. Look how silly this physics is. They're arguing that this cat isn't dead, you know. It's alive and dead. Something did happen, but we don't know it because we didn't open the box. But yeah, we can smell its decomposing flesh, but no, we didn't open it, so we don't know for sure. I mean, it was just so goddamn stupid.
Schrödinger publishes the thought experiment known as Schrödinger's cat, sort of back up Einstein and show the kind of problem that he and Einstein had with quantum physics. Bohr, meanwhile, was like, oh my god, what the hell is this? He must be wrong. How do we show that he's wrong? Then Bohr ultimately, you know, in his sort of painful and complicated style, ends up coming up with a response to the EPR paper.
Right, a piece of crap.
This response is sort of famously obscure and difficult to understand, and I've read it in detail, and I will tell you, Bohr's reply is either nonsensical or makes some actual mistakes.
There's a very well-turned sentence which I believe Bohr took a great deal of trouble in formulating.
So you can't even understand Bell. An influence on the very conditions which define the possible types of predictions regarding the future behavior of the system. Yeah, this sounds like motion theory. Ooh.
And whose meaning is just absolutely obscure to me.
Bohr said...
So Bell couldn't even understand the fucking thing. Amazing.
In his reply to EPR, in his multiple replies to EPR, that there is no question of anything non-local going on. So the ultimate reaction of the physics community, at least in the immediate years and decades following the publication of EPR and Bohr's reply in 1935, was to think that Bohr had settled it with his reply, even though people didn't really understand what Bohr had said.
No, that's not what happened. What happened was a bunch of people didn't like the idea that there's right and left-handed gloves and wanted that wooey thing, like, oh, it's magical, life is random, life isn't determined, we're not just robots, we're not just bugs, being manipulated by forces and circumstances. We're doing some real creative crap. We're being creative and magical organisms. We're spiritual. That's all. You turned it into a fucking religion. That's what they did. They hyped the wrong answer. All right, when the right answer was, it's just left and right-handed gloves. There's no spintanglements or bintanglements or crentanglements or any of this fucking anglements.
2 decades later, Einstein died. Still
2 decades later, it's a pretty long time, for fuck's sake.
questioning quantum mechanics, but the majority of the physics community had moved on without him. Bohr, however, never forgot about the EPR paper. In 1962, 7 years after Einstein's death, Bohr gave an interview about Einstein, and he lamented that Einstein wasted decades on fruitless thought experiments because he simply could not accept quantum mechanics.
Oh, yeah, so that's just shit talk from the shithead. And again, this is the silly thing, right? They have an atom, they have a drawing of an atom, and they actually have the expectation that you people are dumb enough to believe, okay, that, in an atom, that, you have the, a nucleus, and you have a nucleus over here, and you have this electron, and the electron, when it's shared, is doing this. And somehow that keeps those two atoms stuck to each other. This moronic idea that the negative charge that's attracting to the positron, and all this, this takes an incredible speed difference. If you don't change your speed going through all this stuff, you can't do this. There's no solar system where this happens, where a planet goes through here and goes around here. That ain't going to happen, right? There's just no chance in a million, billion, trillion years that could happen. Because all of this stuff is moving and vibrating, and there's no way it would stay regular enough. So there's just no way this would work. But it makes perfect sense if you say, the electron's in one location, and it's attached to this, and it's attached to this, and there's another electron here, and it's attached to this, and it's attached to this, and that makes a very strong bond. These two atoms are sharing these negative charges, and that's a very strong bond. That makes perfectly good sense. But screw perfectly rational explanations. No, let's just accept this moron's religion instead. Let's all just be religious idiots. God, it's so disappointing. Human beings are just you're so disappointing. I just never realized that people were this stupid. This is really stupid. To have these arguments is really stupid. You can't slide across thin ice. Yeah, you can.
It was terrible that Einstein fell in that trap to work with Podolsky, Bohr said. Rosen is worse from my point of view. Rosen even today believes the EPR thought experiment. Podolsky has given it up, as far as I know. The whole idea is absolutely nothing when one really gets into it. You may think that I say it too strongly, but it is true. There's absolutely no problem in it. The next day, Bohr took a nap after lunch and never woke up.
Good. Oh, sorry. Yay! Fuckhead.
And so, after many decades, the Einstein-Bohr debate was over.
Bohr's authority was part of the reason the EPR paper didn't get the attention it deserved.
But there was another reason physicists ignored it.
Because they are wooicists. They're not physicists. They're not scientists. They're not looking for a simple, plain, dull, boring answer. They're looking for a wooey fucking answer.
The EPR experiment, both theories, Copenhagen quantum mechanics...
They want warp drive. They want to travel to the whatever, the something or other thing and go fight the empire, They want to do all that crap.
And Einstein's local hidden variable alternative make exactly the same prediction. You get the same results either way. Debating two different interpretations of the same experimental result seemed like armchair philosophy, not...
I mean, it's fundamentally different, so I don't even know why you would say it's the same thing. It's nothing like the same thing. Gloves happen
physics.
When you build something. You built it the way you built it. You put the piece of wood this way, and so this side was painted, so one side looks white, the other side looks brown. Duh.
The Copenhagen interpretation makes good predictions, so why not just teach that and move on?
It just seems like, shut up and calculate.
Oh, so yeah, it all goes back all the way to Leibniz. Don't bother doing the fucking experiment. Just pretend that mv squared is exactly the same as mv. Yeah, I could just put an equal sign between them. It's the same thing. What's the difference? What's the difference between mv and mv squared? How could something be different about those two equations? How could it be different? It's the same thing. Semantics. Yeah, it's just semantics. 25 times the fuel to go 5 times as fast. Same thing as 5 times the fuel to go 5 times as fast. What's the difference? Same thing. Oh, this is so pathetic.
I think is the message that kind of gets pushed.
The general attitude was, this is done. Who cares?
Exactly. That's the general attitude is, who the fuck cares about an actual rational model of the physical universe that works? Let's just make up all this wooey, wavical bullshit and turn the whole thing into a bunch of sparkly glitter experiments and blender experiments and all kinds of that's it. That's all they did. They turned it into a kid's show, a childish glitter show.
None of this matters. It's all settled. Einstein and Bohr had a big debate about it, and Bohr won. Do you think you're smarter than Niels Bohr? Do you think you're smarter than Albert Einstein?
It seemed like it would be impossible to resolve this debate until another physicist turned...
Right, so they didn't resolve anything. So this is the Bell introduction, and then we get into the big lie of the mustached Italian guy with his proprietary spinning mirrors. What the fuck's his name? It's got a weird name, but anyway.
His attention to it.
John Bell was an undergraduate student shortly after World War II in this
He didn't look like that. He looked really weird.
new era of physics, and so, of course, he was taught the Copenhagen interpretation.
John Bell's doubts about quantum mechanics, by his own recollection, showed up basically the minute he learned it. In his first quantum mechanics class, he was, getting pretty upset with the instructors and saying, you're being too vague. What the heck do you mean about measurement?
Bell was never fully satisfied by the answers he got about the foundations of quantum mechanics. But when he was doing his PhD, he was encouraged to study something a little bit more respectable. And so he studied nuclear physics and went on to have a very accomplished career at CERN. But after 8 years of working in particle physics, in 1963 he took an academic sabbatical. And finally, he had time to focus on his doubts about quantum mechanics. He said, I always knew it was waiting for me. He began by re-examining the old debates and the papers that most physicists had long since dismissed as philosophical distractions, including the EPR paper. After this research, he said, I felt that Einstein...
So he had to invent some idea that there is an actual property that something can have, like a photon can have an actual property, like it can't let go of it, like not a property of just the fact that it's flying through space in a position, but some actual property. So again, it's back
intellectual superiority over Bohr in this.
Back to some argument about electrons having something called a spin. So we're back to this argument that they're going to invent some property that could possibly be entangled between two objects, like they could have some property, and there isn't any such property. It's just woo, and it's just like saying that somehow ESP or something. It's like saying you could have some. I have a twin sister, that somehow we really would have some kind of spiritual connection, like there'd be some kind of thing that tick 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 inside my brain, that tick 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 the same inside hers or something. And it's just sort of bullshit. You can say that no, all we can have is a common mother and father. And a common time of arrival. I mean, it's just too silly.
This instance was enormous, a vast gulf between the man who saw clearly what was needed and the obscurantist. He realized Einstein's logic was sound. One of the two conclusions is true.
The question was, could you prove which one using an experiment?
An experiment of this sort seemed much more feasible by Bell's time. The EPR paper was the first to consider the idea of entanglement.
Yeah, but it wasn't. It didn't use spin. It didn't describe antimatter. None of that shit was in the paper. So again, don't imply that the paper was about any of that wooey crap.
These days, entanglement is a core feature of quantum mechanics. But Einstein had been first.
Yeah, a core feature not demonstrated by any experiment that one could call visually clear. Yeah. I wouldn't call them good experiments just because of the fact that there's too many black boxes where they claim it's doing something, but we can't see what it's doing.
To even point out entanglement existed. This is why the EPR paper was set up as a thought experiment, because no one had made such an exotic state of matter in 1935. But in the intervening decades between Einstein's work and Bell's, between 1935 and 1964, entanglement had become a serious topic of study. By Bell's time, there were reliable ways to make it in the lab. In fact, Madame Wu had famously reproduced the EPR thought experiment as a real experiment.
Oh, who said so? Again, this is just so Madame Wu. Where did she come from? Never heard of Madame Wu. You know, my whole life. Oh, she did it first. Oh, okay, sure she did.
But simply doing the EPR experiment in real life isn't enough to tell you which explanation is correct, since both predict the same thing.
So again, saying they're doing this experiment where they have some kind of, again, something moving the speed of light,
But
and they're going to measure the same piece of photon, the same thing, there's no chance. This is all just wooey talk.
Bell wondered if there was another version of the experiment where the non-local and local theories would have to give a different result.
If you're asking that question and you're playing with the EPR setup, then it's like, oh, it's literally, not just figuratively, a twist, right?
Here's a simplified version.
And so then they're going to do the mathematics, and let's understand they changed the mathematics. I mean, the original mathematics by Bell came up with a 1 as the answer, and then, you know, a little bit later, all of a sudden the answer was 2. You know, so it wasn't even consistent.
Of Bell's experiment. Make your entangled electron and positron again.
All
But
right,
now,
so now
instead
they're-
of just measuring them with a Stern...
So again, so this is just absolute lies. There's no Stern-Gerlach you can use with electrons and protons. None of this shit exists. There's no positrons in any experiments. I mean, this is just completely made up lie. I mean, why they get away with this? Why can't they tell us what they're really going to measure? What they're really going to use in the experiment? Because they're not going to do this. This isn't going to happen. It's a lie.
Gerlach machine like this, the experimenters get a choice about how to orient their machine. The 3 different choices are 0 degrees, 120 degrees, and 240 degrees.
So this is about polarization. So again, now they're showing you just, look how much they're lying here. Because that's what matters, right? Polarization, you could understand that polarizing films, it matters what your angle is. So this is about polarization, and now they're going to pretend that Stern-Gerlach has something to do with this. It has nothing to do with this. You can't orient Stern-Gerlach machines like this. You can't play this game. It doesn't happen. It doesn't work. I mean, this is such a lie.
This is the twist on the EPR experiment. The experimenters get to choose independently. So the electron might be measured at 0 degrees.
So they're just measuring the polarization of a photon. They're not measuring anything called spin, and they're not measuring anything called a positron.
While the positron is measured at 240 degrees. If both experimenters happen to choose the same axis, then we know what happens. They have to get the opposite result as each other, to conserve spin. The interesting case is when the experimenters happen to choose different axes. The number we want to predict here is the disagreement rate, the probability that...
So again, this is just such... I'm just, like I said, I can't believe that there's no people that pop in here randomly or whatever. People watch these videos, and none of you people think this is really evil. That they're describing an experiment that doesn't exist and doesn't take place. They've never done. This isn't Alan Aspect's experiment. This isn't what he did. This isn't what he got a Nobel Prize doing. This isn't what Madame Wu did. She didn't do this experiment. Why are they illustrating an experiment can't be done? There's no equipment that can do it. There's no mechanism can do it. Why are they using this as an example? Why? Because if they used the polarization of the light, you would recognize, oh, wait a minute, but I already know that polarizing filters just break photons, and I can put a third filter in, and I can get all my photons, I can get half my photons back again. That I'm not really measuring anything. I'm just changing the phase of the photons. So this is such a deception. Such a lie. They're just such liars.
the electron's result is different from the positron's. First, let's see what quantum mechanics predicts for this number.
And you could also understand how difficult it would be to actually test photons, over a distance, traveling a distance, and say, oh, I got the same photon. Guaranteed. Yeah, no, maybe not.
Let's say the electron is measured with the 0-degree axis and comes out as plus. Now that its spin has collapsed to positive z, the positron spin needs to instantly collapse to be negative z. This is the non-local part of quantum mechanics. But what happens when this positron is measured by a machine tilted at 120 degrees? You can see that the positron spin is already almost facing the plus end of the machine, so it's much more likely to go to plus. In fact, there's a 75% chance it goes to plus and only a 25% chance it goes to minus. So the disagreement rate is 25%. And we can show that for any two different axes the experimenters select, the geometry is analogous.
So this just has to do with you getting those photons back. The 25% is exactly, it's 22%, I think, with polarizing film. But that's what you're really just talking about, is when you can put one in at 45-degree angle, you can get 22% of your photons back. This experiment is about fucking polarization. And polarization is about phase. That's what polarizing filters do. Polarizing filters, if you don't know, work on... Whoa, that was interesting. See how far I could move this. I should just erase that, I guess. That would be safer. Yeah, I erased most of it anyway. All right, so what was it going to show? Polarizing... the filter. Okay, the film. Polarizing films are like this, okay? So it's a layer, and the layer has a thickness. Now, one layer causes a phase shift. And then if you put a second layer on, okay, and that's what they do. They put a second layer on in stripes. So in little tiny thin lines, there's a second layer. And that's a polarizing film. So you can understand that some of the photon, some of the energy, goes through two layers. Some of the energy only goes through one layer. And so what happens is, if there's a frequency, what ends up happening is this bit ends up being put down here, let's say, out of phase, because it went through two layers. So now it's 90 degrees out of phase. And so you just... Why isn't that visible? Oh, it's way up here. That's why it's not visible. Yeah, sorry. So the photon is here, and the bit gets knocked out of phase because it goes through two layers. And then all you're really saying is, I could put another filter in, and I could end up putting that bit back where it belongs. I could put it back in phase again. So you're just playing with the phase of the photon bits. You're taking the Morse code signal, and you're just playing with the phase of the signal. But again, they're just they make you think that these filters break destroy photons, and they really don't. The energy doesn't get absorbed. These filters don't get hot. They don't absorb photons. They don't make them disappear. They just take the bits and rearrange them. So there's fewer of them that are visible photons, but the energy's still there. The pieces are all there, and all you have to do is rearrange them, and you got your photons back again. It's just a fact. You can do that. You can just keep putting filters in, and you can get all your photons. You can get 90% of your photons back by just putting more and more filters in. Fact.
So they all have this same disagreement rate of 25%. Anytime the experimenters choose different axes, they will get the same outcome 75% of the time, and different outcomes 25% of the time.
Now let's consider the local hidden variable alternative theory.
The particles here are on a mission. Their aim? To make you believe that they're acting according to quantum mechanics, when really they're acting locally.
Now we are anthropomorphizing, but I think it is really useful.
Oh yeah, I think it really is useful to make it all a cartoon and fun for little kids and stuff, because it's all fake and phony anyway. Oh, I hate you people. I really hate you.
To just imagine them this way.
We're trying to figure out if it's always possible for them to use a hidden variable theory to get the same experimental outcomes as Copenhagen quantum mechanics, or if in this new situation, our scheming particles won't be able to fool us. You can think of it like this.
Oh, I don't think there's any way to think about this and understand what the fuck they're trying to tell you, is somehow they can tell the difference between those two circumstances. right and have gloves, and then gloves that get invented while they're on the spot. Sure.
Each of the particles is going to be asked one of 3 possible questions, and they need to decide on their answer while they're still together, so that they can coordinate on their strategy. When they're done figuring out a plan for how they would answer...
Alright, so just this is amazingly convoluted. Like, how the fuck does this make any sense? What properties are you talking about? How can they possibly be doing all of this? They're fucking dumb particles. Amazing.
Any of the 3 questions, they pack away those hidden variables into 3 sealed envelopes for each particle. The question is, what strategies should our sneaky particles take to make people believe that they're following quantum mechanics? Remember, quantum mechanics predicted a disagreement rate of 25%, and so our particles want to match that. Whenever they happen to be asked different questions, their answer needs to disagree about 25% of the time.
So, what's the best strategy? Well, there's actually only 2 things that they really can do. The first strategy is this. The electron answers the same way for each of its axes, and the positron answers in the opposite way. Let's say the electron answers with minus, and the positron with...
So why do we have 3 envelopes now? What's all this about?
plus. But
I mean, you know, they have 2 lines going this way and a line going this way. Well, why don't they have a line going some other angle? Just to throw it in there to see what happens with the other angle.
this is a terrible idea, because whatever 2 different axes the experimenters happen to choose, the disagreement rate is 100%, which is very different from 25%. And so that strategy doesn't work. But there's only one other strategy that the particles could use. Instead of the electron doing exactly the same thing for all 3 axes, it does the same thing for any 2 of its axes, and then something different for the last one. Let's just say, for example, that it does this.
I mean, obviously 2 of the axes are symmetrical, opposites of each other, and one of them isn't. So I don't even know why this is relevant, but whatever.
And then the positron does the opposite. This is just one example, but it turns out for all possible strategies like this.
So there's no positrons, there's no experiment with positrons, it's all just a lie. I don't know why they're saying there's positrons in the experiment, there's no positrons. Why are they using positrons as an example? It's no positron experiment.
The disagreement rate is going to be the same. Let's imagine first that the experimenter who's measuring the electron happens to measure it in the 120-degree axis, and it gets the answer minus. They make this choice a third of the time. And now, to calculate the disagreement rate, we need to see what happens when the experimenter who's measuring the positron happens to measure a different axis from this one. So one of these 2. But in either one of these cases, the positron is also a minus, and so the 2 answers agree with each other. And so the answers have no disagreement. And so we can multiply this by 0. But 2/3 of the time, the experimenter who's measuring the electron will happen to measure it in one of the other 2 axes. Let's say this one. The experimenter measuring the positron will measure in one of these 2 axes. But you can see that they only pick an axis that disagrees.
Okay, so she's heading for 2 as the number, right? So 1/3 plus 2/3, we're up to 1, and now she's going to come 3/3.
Degrees half of the time. That's 1/3, which is roughly equal to 33%, which is a different number from the quantum one.
When our scheming local particles are interrogated, their answers for different questions match just a little too often. They simply can't fake the results of Copenhagen quantum mechanics.
So, and again, this obviously none of these results, none of this is scientific. All of it's a wooey experiment. All kinds of room for fudge. And we're all supposed to believe because of these fudgy, wooey experiments.
So Bella's proof showed that non-local and local theories make different predictions about how often the 2 results will disagree.
I don't know if he proved that, but frankly, okay, you say so. I don't think so, but whatever, you say so.
The experimenters measure different axes. Non-local quantum mechanics predicts disagreement only 25%.
This, again, all of this has to do with light polarization. So all of this theory was based on how they understood at the time how light polarization worked. And this is before they had figured out the polarizing filter trick, you know, where you stick the third filter in and you get your photons back. This is before then.
Of the time. Local hidden variables predicts disagreement at least 33% of the time. So to find out if they're really...
So they're saying what a prediction, so just like before where they said Newton said gravity was instantaneous, or Newton said gravity is distance dependent, or some other lie, this is just another lie where they're saying so. They're saying this is what you would expect. Well, maybe it wouldn't be what you would expect. Maybe you'd be smarter than they are, and you wouldn't think something stupid would be true. So when they say they were expecting 22%, who was expecting it? Prove to me somebody reasonable expected it. You know, you just made it the fuck up is what it comes down to. They're proving something that, you know, that we're supposed to assume it's an established fact when they haven't established the fact. They're telling us it takes 25 times the fuel to go 5 times as fast. Do they have any evidence? No. Should you believe it? No.
Is a local hidden variable theory? You just need to do the experiment.
Okay, so welcome at the Institut Optique.
Oh, it's disgusting. They're going to go to that fucking shithole Paris. I thought it was Spain or something, but anyway. So they're actually going to go to this shithole's fucking experiment, this piece of crap experiment. You know, that they've never repeated, frankly.
You are here in the place where Alain Aspect performed.
Alain Aspect, the big giant mustache man, did famous experiment. See all the black and white feed photograph. Yeah, he proved, did. Nobody need to do no more because we already did. It's all do, and did. So nobody need to do no more. No more. No. Ice cube's cold. I prove. Put ice cube on head, cold. Yeah. Proven, done. No more experiment. Me fucktard. Yes, you are fucktarded.
40 years ago, his experiments on the measurement.
Yes, 40 years ago, he did this crap experiment, claimed a bunch of stuff in his leather jacket as he did his fucking photon experiment where he claimed, I measure photon 10 feet away. I measure it. I did it. I have special tool. I have special power. I do these things because I'm a special man. Complete bullshit.
Of Bell's inequalities, and here are some of the original pictures of this experiment.
Yeah, here's the original crapola. Can I show you a new crapola? Here's maybe a new piece of crap. Can we run the experiment and show you it doing anything? No, because it's all in black boxes. The black box says yes, or the black box says no. Okay, I don't get to see nothing. Black box see it. Don't you believe in black boxes? Black boxes are God. They tell you everything.
Which was much more challenging than it is today, and it was a real experimental tour de force.
Pile of shit.
So is this one of the original equipment from that?
This is one of the polarizer,
the magical mirror spinning devicey thingy that make all kinds of different photons go all kinds of different places. Magical spin. I patent it. I sell you one. You'll give me lots of money, I'll give you one. No, you can't have one. You can only use one. Yeah, that's the deal. You can only rent it. I only rent science. You can't have it. You can only rent it from me.
Looks like that now. So only on this small breadboard, right? It's our main source. And this beam is directed towards this element, which is the key element of the setup. So it's a pair of crystals that produces pairs of...
Ah, they changed the volume somewhere in here, right? Yeah, I can't hear this now. I'll have to crank it up a little.
Centennials, photons. We will produce...
So again, photons. Polarized fucking photons. No positrons, no electrons. fucking photons.
A pair of entangled photons.
The pair of entangled magical photons that we say are this, and the other thing, blah, 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 right? All bullshit.
And both are propagating along each of these two arms. They are separated. So here we have the two detection arms.
So they're supposed to be actually at, I think, 70 degrees, which is a pretty substantial angle. So he's showing photons coming out pretty close, like 20 degrees. So I don't know. That doesn't seem right to me, but whatever. Let's play along.
And we can rotate the half-wave plate to change the orientation of the measurement basis.
Yeah, orientation of the measurement. Changing the polarization filter. I'm just going to change the orientation of the polarization filter. I mean, what the fuck? Why is he making this the... Oh yeah, I'm going to change the spin detector. No, you're not changing a spin detector, you liar. Oh, this is still disgusting.
The experiment that we did with light was a little bit different from the one we described earlier.
Oh, yes, it was completely different. The one you described earlier was completely made up and never took place in the history of mankind. It was complete rubbish and nonsense that you just phantasmagorically made up that absolute shit and just fooled everybody. You're just a deceiver and a liar. Why the fuck would you have made up that fake fucking story about the abominable snowman eating Yogi Bear? Why did you make up that fake story?
Electrons and protons. So
No, you use positrons, you fucking bitch. Oh, sorry. But you use positrons, you fucking bitch! Jesus Christ, that's even worse. Protons would have been a lot more rational. Positrons is crap physics. Oh, damn it. I just hate this planet.
I'm going to explain how they correspond. Here's a little diagram of the photon experiment.
Yes, so I'm going to somehow going to explain to us why they drew the experiment, showed the experiment, animated the experiment with a bunch of lies. Okay, that don't have anything to do with the experiment. She's going to explain why they're lying. Okay, well, I'm going to go get a drink so you can watch why they're lying. So 31. Okay, so I'll come back and see it, but I'll let you see it ahead of time.
So first we have this element that makes the entangled pair of particles. That's these two. Then the entangled particles go off on separate arms of the experiment. In our previous experiment, we could decide the direction that we're going to measure the particles in by rotating the Stern-Gerlach machines. And in this experiment, it's actually really similar. So we have these two polarizers that we're able to rotate independently. And that is going to decide which direction these particles are measured in. And so this experiment with light is completely equivalent to Bell's experiment.
Bell expected that the experiments would show that the predictions of quantum mechanics were correct and that there was some kind of non-locality in nature.
Before the first Bell test was done, John Bell said, in view of the general success of quantum mechanics, it's very hard for me to doubt the outcome of such experiments.
He didn't expect quantum physics to be wrong, because who would bet against quantum physics? You'd have to be crazy.
Remember, the two different outcomes for Bell's theorem depend on how often two different measurement axes are going to have results that disagree with each other. Here's how we measure that disagreement rate. First, we're going to start with both of the measurements being in the same direction. And now we expect that these two are always going to disagree with each other because they have opposite spins. So we're going to create a bunch of entangled particles and find out how many of them disagree with each other per second. This is going to give us a measure of the total number of particles coming per second. That's because this device is making loads and loads of entangled particles, and so we just need to know how many of them are coming at a time. Then we rotate one of the axes, and now we measure the number of disagreeing pairs per second. And then dividing these two will give us the disagreement rate. And remember, quantum mechanics predicts that the disagreement rate will only be a quarter, whereas local hidden variables expects this number to be a third.
So I started at 2000, right? And now I have 500. So that really works pretty well.
We did do this experiment again, and the number we got very much agreed with quantum mechanics. But this is one of the most misunderstood experiments in all of physics.
You will find in all sorts of physics textbooks and papers and whatnot that what Bell's theorem proves is that it rules out local hidden variables or local realism. John Bell said that was an error. He said, like, it's really quite remarkable how many people make that error.
I always get confused at the conclusion of Bell's theorem. Yeah. Because there's a lot of people who say, like, okay, it rules out hidden variables, or things have to be non-local, or whatever. But what do you think?
Yeah, I think it is super confusing. And when I first learned Bell's theorem, I was told that it rules out local hidden variables.
I've heard this other argument that it sort of disproves either locality or realism.
If you say, okay, it means that you give up local realism, and so that means you somehow have a choice between giving up locality and giving up realism. If you're giving up realism about what? Like you gotta tell me, because like for most definitions of that word, you'd also be giving up locality. So what the hell are you saving? I just don't. Yeah, it's a really deep misunderstanding that shows up in almost every single textbook on the subject.
So what does Bell's theorem really prove?
Well, here's the logic. Start by assuming locality for the entangled particles. Using the EPR argument, the only way for them to coordinate their outcomes is using local hidden variables. Then, Bell's proof showed that local hidden variables predict an incorrect experimental result. Therefore, the assumption of locality must have been wrong.
We're obliged to invoke something like actions going faster than light from one place to another.
The EPR paper by itself had shown that the Copenhagen interpretation is non-local, which is why Einstein thought there must be an alternative way to describe the experiment that is local. But Bell's theorem says that's not true.
Any theory that correctly describes this experiment must be non-local.
But I would hesitate to say that means that Einstein was wrong, right? Because what I would say is this shows that Einstein was right to be concerned about all of this.
People often claim that Einstein's problem was that he simply couldn't accept quantum mechanics, but it was only because he refused to shut up and calculate that he discovered two of the most important aspects of quantum mechanics: entanglement and non-locality.
The heart of the debate between Einstein and Bohr was about whether there was a problem, whether there was something to be concerned about. And the major concern that Einstein brought to the table from the beginning was about locality. But what Bell showed was, oh yeah, all that stuff that Einstein was concerned about locality, he was completely right to be worried about it. We have a problem.
If these particles really are acting non-locally, this should cause paradoxes, shouldn't it? Well, it does, but the paradox seems to be surprisingly tame.
Imagine you and your friend are measuring a pair of entangled particles. Suppose an observer sees you measure yours first and then your friend measures hers. That observer thinks that you collapse the overall state of both particles and your friend just finds out the result when she measures. But another observer will see the situation in reverse. They see her measure first and then you. To them, it was her measurement that caused the collapse, not yours. But who's right? Which measurement was the cause of the collapse, and which was the effect? It seems to depend on your frame of reference.
This paradox is worrying, but it isn't as bad as the usual faster-than-light paradoxes. In relativity, if you can communicate faster than light, then you can exploit how different observers disagree about timing.
If you're...
All right, sorry, that was a little longer. I didn't realize it would take that long to make coffee. But anyway, so let's see, that's about where we were, this silly part. Yep. Oh, such a lie. All right. All of this lying. Why do they have to do all of this lying?
The orientation of the measurement basis.
The experiment that we did with light was a little bit different from the one we described earlier with electrons and protons. So I'm going to explain how they correspond. Here's a little diagram of the photon experiment. So first we have this element that makes the entangled pair of particles. So that's these two. Then
so they're not particles, they're photons. So it was just such a lie.
Entangled particles go off on separate arms of the experiment. In our previous experiment, we could decide the direction that we're going to measure the particles in by rotating the Stern-Gerlach machine.
So there's no Stern-Gerlach machine. This is just such a crap. Oh, God damn it. They're just throwing these different... I don't even know what they're doing. the scissor, toenail cutting, pin up your ass experiment. I mean, they're just putting different things together. This is a crocodile duck thing, right? A crocoduck or whatever. This is just like with the religion. This is the spaghetti monster. I mean, what the fuck is this bullshit? How do they get away with this? How do scientists take this shit seriously? I mean, this is mockably bad.
And in this experiment, it's actually really similar. So we have these two polarizers that we're able to rotate independently. And that is going to decide which direction these particles are measured in.
So again, just to make any sense, which direction they're measured in, how can it make any difference? You're just changing the polarization. It means you're changing what photons are actually there. You're not physically changing a photon. You know, when you change the polarization, you're killing this photon and you're making this photon. Oh, it's just such bullshit. You're not actually bending photons.
And so this experiment with light is completely equivalent to...
So all of this is based on assumptions, right? So if you actually assume that a polarizing film can actually take the discrete bits of energy, right, flying straight line vectors, and actually bend them, okay, that you can actually bend photons. You can't. You have to mechanically do it, and mechanically means you're doing it by changing what the photon is. You're changing what it's made out of. So they can't possibly be entangled anymore. Yeah, because you've rebent them. It's not even that you've bent them, you recreated them.
Bell's experiment.
Bell expected that the experiments would show that the predictions of quantum mechanics were correct and that there was some kind of non-locality in nature.
Before the first Bell test was done, John Bell said, in view of the general success of quantum mechanics...
all right, there's no general success. It's just such a pile of shit. So again, this is all what they wanted to defend. They wanted to find this. That's their goal, and they just created an experiment to find it. That's it. This is just like the invention of the positron in the first place. It's just they want to find a positron. So they'll just put a dress on a proton and call it a positron.
It's very hard for me to doubt the outcome of such experiments.
You didn't expect quantum physics to be wrong, because who would bet against quantum physics? You'd have to be crazy.
Remember the two different...
Oh, god damn. Who would bet against ESP particles? Yeah, who would bet against that?
Outcomes for Bell's theorem depend on how often two different measurement axes are going to have results that disagree with each other.
So what they're doing is repolarizing the light and then measuring its phase change when the polarizers are changing the phase. So you see how circular this is getting right away? They're using phase-changing polarizing films to detect a phase change that they're claiming exists because of a quantum effect, when of course it exists because of the turning of the polarizing film effect.
Here's how we measure that disagreement rate. First, we're going to start with both of the measurements being in the same direction. And now we expect that these two are always going to disagree with each other because they have opposite spins. So we're going to create a bunch of entangled particles.
Right. Okay, whoops, I just blew it up again. Sorry.
In 1935,
prediction. You can get the same results either.
All right, so, we went past there. Yeah, we're way down here by now. Okay. All right, we're past there. Past there. Past there. Come on, where is it? Somewhere in here. I think.
I was told that it rules out local.
Okay, so go back a little. Now, go back a little further. All right, so they're in alignment disagreement rate. Okay. So just to understand what they're claiming is that there's two separate properties, and there isn't two separate properties. There's just phase. And that's all they're going to measure, is the phase shift. And they're going to claim that, where she just said, we'll shoot many particles, that means they're going to make a lot of these events happen. And the whole idea is to say, well, you just want the one event. You want the 2 photons in the experiment, that's it, no others. Because the more you have in the experiment, well, now you can have photons from different events, and you're not even going to be measuring the same thing anymore, right? But the fact is they can't measure the single photon, because it's not enough energy. You see where this goes all kinds of sideways? Because they all have to be entangledly created photons. So this is just bullshit, that they could measure any of this crap. And I still don't know what the spinning mirror was for. I mean, Alan Aspect's experiment has a spinning mirror in it. What's that for?
Spins. So we're going to create a bunch of entangled particles and find out.
So how do you do that part? How do they do this bunch of entangled particles? And then if there's a bunch of them, how do you tell which ones are supposed to be? How do you measure them correctly? You get me? If there's a whole bunch of them, how do I know I got the right blue one with the right red one? How do I know I'm measuring the right pairs? Because they're all going to be within the same milliseconds of each other. How do I know I'm measuring the right ones?
How many of them disagree with each other per second? This is going to give us a measure of the total number of particles coming per second. That's because this device is making loads and loads of entangled particles.
Oh, fuck.
And so we just need to know how many of them are coming at a time. Then we rotate one of the axes, and now we measure the number of disagreeing pairs per second. And then dividing these two will give us the disagreement rate. And remember, quantum mechanics predicts that the disagreement rate will only be 1/4, whereas local hidden variables expects this number to be 1/3.
Right. And they're going to measure these kind of differences with this shit experiment. And even if I was to
So I
concede...
started.
What the hell was that? That was a hell of a jump. I didn't do that, did I? No, I didn't do it.
Will only be 1/4, whereas local hidden variables expects this number to be 1/3.
So I started at 2000, right? And now I have 500. So that really works really well.
We did do this experiment again, and the number we got very much agreed with quantum mechanics.
Yeah, we did it, and so I didn't bother filming it for you or explaining any of the experiment, actually how it worked.
But this is one of the most misunderstood experiments in all of physics.
You will find in all sorts of physics textbooks and papers and whatnot that what Bell's theorem proves is that it rules out local hidden variables or local realism. John Bell said that was an error. He said, like, it's really quite remarkable how many people make that error.
I always get confused at the conclusion of Bell's theorem, because there's a lot of people who say, like, okay, it rules out hidden variables, or things have to be non-local, or whatever, but what do you think?
Yeah.
Well, they're claiming 2 different results. One was local and one's not. So if there's 2 different results, 25 versus 33, and you're saying one of them believes something, well, then I don't see that's pretty clear. But I don't even understand why they're saying the local happening would be the 33 happening and the 25 is for the non-local. How are they doing local and non-local in the same local experiment? How are they proving a non-local?
I think it is super confusing. And when I first learned Bell's theorem, I was told that it rules out local hidden variables.
I've heard this other argument that it sort of disproves either locality or realism.
If you say, okay, it means that you give up local realism, and so that means you somehow have a choice between giving up locality and giving up realism. If you're giving up realism about...
Yeah, realism about what exactly? What are you actually measuring? Are you measuring exactly the same photons? And again, I would argue as soon as you change that filter on the polarizer, you're changing what photons you're making. Which ones will be photons and which ones aren't. You're just there's a bunch of little bits going through, little dots. And you're just changing which dots are going to be photons and which dots are going to be invisible tons. And that's all you're doing.
What? Like,
Half of the photons going through the filter are going to be turned into non-visible photons with just one filter.
you gotta tell me, because like for most definitions of that word, you'd also be giving up locality. So what the hell are you saving? I just don't. Yeah.
It's very articulate. So at least it sounds like he's on my side now. Hey, it's all bullshit. Why are they talking all that shit?
It's a really deep misunderstanding that shows up in almost every single textbook on the subject.
Well, great. So it's a great subject, isn't it? Nobody can really talk about it because it's all so convoluted and silly that it's just that, too convoluted and silly. So why don't you just start the fuck over and find a real experiment and really prove some of this crap you claim. So go ahead and show me something being entangled. Show me something entangled.
So what does Bell's theorem really prove?
Well, here's the logic. Start by assuming locality for the entangled particles. Using the EPR argument, the only way for them to coordinate their outcomes is using local hidden variables. Then, Bell's proof showed that local hidden variables predict an incorrect experimental result. Therefore, the assumption of locality must have been wrong.
We're obliged to invoke something like actions going faster than light from one place to another.
The EPR paper by itself had shown that the Copenhagen interpretation is non-local, which is why Einstein thought there must be an alternative way to describe the experiment that is local. But Bell's theorem says that's not true.
And let's understand, the whole problem with this double-slit experiment was just their perverse interpretation of, again, what the fuck they're doing with photons. They're not, you're breaking photons and then remaking them again. It's the same argument. The surfaces are breaking photons. All of the fringe light is light that went by the surface. That can be proven. You can absolutely prove that it's essential to create fringe light. You have to increase the amount of surface. And so the more surface I make, that is, the higher the percentage of surface to open space, the more fringe light I create. Demonstrating that it's a surface phenomenon. I mean, goddamn.
Any theory that correctly describes...
So all of this doesn't have to be believed. You don't have to believe their silly notions that these are the same photons and you're not changing the machinery, the variable, right from the start, that the surfaces are actually breaking the photons and you're just remaking them on the surface and you have a 50-50 chance of them being in phase or out of phase. Duh. You're throwing little bits, and there's a 50-50 chance they're in phase or out of phase.
This experiment must be non-local.
But I would hesitate to say that means that Einstein was wrong, right? Because what I would say is this shows that Einstein was right to be concerned about all of this.
People often claim that Einstein's problem was that he simply couldn't accept quantum mechanics. But it was only because he refused to shut up and calculate.
Okay, no, that's not. He really didn't think the universe was run by gods. It wasn't run by pixies. It wasn't run by hobgoblins. It had to be something real. Now, obviously, his gravity theory wasn't real, so I can't make an argument except to say, well, shit on him for wanting reality in one side of physics and then not demanding it in the other.
That he discovered two of the most important aspects of quantum mechanics, entanglement and...
He didn't discover entanglement. So again, it's just a lie. It wasn't something he believed in. So again, it's just such nonsense. Einstein didn't believe things were entangled. Why would you say he discovered entanglement? I mean, he's argued against it. I mean, it's just such bullshit.
Non-locality.
The heart of the debate between Einstein and Bohr was about whether there was a problem, whether there was something to be concerned of.
Yeah, mechanics is all the argument it's about. Einstein figured the universe has to have a mechanism. There's a continuity somewhere. There's a unifying explanation for functions. And that's what he just knew that entanglement and woo was going to ruin any hope of that.
And the major concern that Einstein brought to the table from the beginning was about locality. But what Bell showed was, oh yeah, all that stuff that Einstein was concerned about locality, he was completely right to be worried about it. We have a problem.
If these particles really are acting non-locally, this should cause paradoxes, shouldn't it? Well, it does, but the paradox seems to be surprisingly tame.
Imagine you and your friend are measuring a pair of entangled particles. Suppose an observer sees you measure yours first and then your friend measures hers. That observer thinks that you collapse the...
So again, they're doing this fucking of when do you observe something? When do you see it? Not when it actually happened, but when do you see it happen? I mean, too silly.
overall state of both particles, and your friend just finds out the result when she measures. But another observer will see the situation in reverse. They see her measure first, and then you. To them, it was her measurement that caused the collapse, not yours. But who's right? Which measure?
Well, again, this is also obvious that if I'm standing on this side, the right side of this thing, and you said that there was a gunshot and that caused an explosion. The fact is I'm closer to the explosion, so I won't hear the gunshot until after the explosion. Now, because I'm closer to the explosion, right? So if I'm if I'm all the way out to the right side of that image, right? And the red thing is the explosion, and the blue thing is the gunshot. And the gunshot is going to come after the explosion, because I'm really close to the explosion, going to get that sound right away. And it's going to take a while for the gunshot to get to me. You see? And then I go the other way around as I hear it. Okay, hear the gunshot first, and I hear the explosion way later. So what's the point of this shit? There's no paradox. I don't know why people are this dumb. This is just dumb.
Measurement was the cause of the collapse, and which was the effect? It seems to depend on your frame of reference.
This paradox is worrying, but it isn't.
No, it's silly. There's no paradox.
As bad as the usual faster-than-light paradoxes. In relativity, if you can communicate faster than light, then you can exploit how different observers disagree about timing.
If your friend who's on a rocket sends you an instant message, and you send an instant message back, in some frames of reference, your message can arrive before she even sent the first one. If your message says, "Don't send your original message," and so...
Yeah, I mean, obviously, if you can send something faster than the speed of light, you're breaking the practical rules of function. So, yeah, it ain't gonna work.
If she doesn't, then you've got yourself a paradox. What prompted you to send this message if she never sent you anything in the first place?
Quantum mechanics sidesteps these paradoxes through a fundamental constraint. The outcomes are random, so you can't send messages faster than light.
When you measure your particle, you get a plus or a minus completely at random. Your friend measuring their particle also gets a random result.
Yeah, but that's not random if you make sure you send the particle, you have some mechanism to de-randomize. So if you know something about how to make the particle come out, an outcome in a certain amount of time ticks or something, you find out some defect, well, then you can send messages. So again, that's not really viable, that this is all about random. I mean, how could the spin be random, right? It has to have a rotation speed, it has to have something, you know, all these mechanisms would have to have some kind of mechanism. So unless you're saying it's non-mechanism and it's just innately random, I mean, isn't that baby talk? It's an innately random thing? Yeah, no.
Now the results will be correlated, but they're still completely random, so there's no way to send any faster-than-light message in this way.
That's what prevents us from sending messages back in time using quantum mechanics.
So quantum mechanics is non-local, but it doesn't lead to the sort of catastrophic paradoxes you might expect from relativity. But it's an uneasy truce. Quantum mechanics may not break the letter of relativity's laws, but it certainly violates the spirit.
So both the theories are garbage, so who cares? That would be my simple argument. Who cares? Because bad theory, bad theory. Oh, there's a contradiction between two shitty theories. Oh, well. Isn't that just horrible?
And non-locality isn't the only troubling thing about quantum mechanics. The Copenhagen interpretation still doesn't explain what an electron is really doing, and why it acts so differently when measured.
Despite this, many physicists took Bell's
So
theorem.
again, more crap about measuring, no experimental evidence, no showing me how you measure an electron, and what the fuck you're measuring. They just keep saying this stuff happens, but there's no evidence of any of it happening.
To mean that the Copenhagen interpretation was right all along. Bell himself rejected this.
He spent the rest of his life championing alternative interpretations of quantum mechanics, including the hidden variable interpretation called pilot wave theory or Bohmian mechanics.
Yeah, garbage.
Bell's theorem doesn't rule this interpretation out, because the pilot wave theory is non-local, just like the Copenhagen interpretation. It was Bell's theorem and Bell's subsequent tireless work that made studying the meaning of quantum mechanics respectable again.
He showed that mere armchair philosophy and thought experiments can have real consequences in physics.
All right, so just again, all this bullshit, and it's all because they've exaggerated and perverted every bit of this story. And again, they showed it. When they do the actual experiment, they're not doing any of these fucking experiments they're claiming they're doing.
We need to be teaching quantum physics in a different way. We need to be teaching Bell's theorem in a different way. We do often teach Bell's theorem to physics students, and it's taught as something that rules out local hidden variables. That's just not true. Bell's theorem, says that quantum physics is in very serious tension with relativity on the issue of locality.
John Bell passed away suddenly at the age of 62. He didn't know it, but he had been nominated for the Nobel Prize just a year earlier.
In a talk he gave in Geneva in January 1990, he said, "I think you're stuck with the non-locality. I don't know any conception of locality which works with quantum mechanics." That was 8 months before he died. So pretty much his last word on the subject.
And so that's it. There really are faster-than-light influences in the universe.
Says you. Because Bell says so. Oh, gee, it's just hilarious. So Bohr says so, Bell says so, then everybody has to believe it. Amazing bullshit.
Bell's theorem proves it.
Oh, fuck you.
But maybe there is a way out. There is another way to interpret quantum mechanics that's even more bizarre than the Copenhagen interpretation. Imagine the EPR thought experiment again.
Oh no, he's going to do the many worlds thing. So this has just gotten so bad. The Sean Carroll bring up this wooey theory. Oh, we have new universes just poofing into existence, and we're all part of all those universes, so we get to exist a zillion times in all kinds of horrible, disgusting ways. How fucking charming.
We can think of the entangled state as being in a superposition of the electron being up and the positron down, and the electron being down and the positron being...
So why do they keep talking about electrons and positrons when they don't do any electron-positron experiment? Why? You do have to answer that question. Somebody has to answer the question. Why are they using this fake analogy?
Up. In the Copenhagen interpretation, when you measure a particle and you get only one result, say plus, the other part of the superposition collapses. But in our examples, we've seen that measurement collapse seems to be the source of non-locality. So why don't we just get rid of collapse altogether?
This is what the many worlds interpretation of quantum mechanics proposes.
When you measure a particle, instead of you collapsing the particle to one outcome, both outcomes happen, and there's two parallel versions of you who sees each outcome. You have become entangled with your particle because your state depends on what the particle is doing.
It sounds strange, but there's one huge benefit of this interpretation.
When your friend is about to measure her electron, your positron doesn't need to rush to tell the electron what the answer will be. There are already two versions of the electron, and they contain the right answer for each version of her. There was no need for faster-than-light communication to explain the EPR experiment.
But how is that possible? Doesn't Bell's theorem prove that the two particles must communicate faster than light?
Well, in Bell's proof, we assumed that all measurements have just one outcome. But that assumption just isn't true in many worlds. This means that technically, that proof doesn't even apply in the many worlds case.
So is many worlds local? In one sense, no, because just like in Copenhagen quantum mechanics, entangled pairs can be separated by a huge distance and still share their state. However, it is local, unlike Copenhagen, in the sense that these faraway entangled particles do not influence each other faster than light. Many worlds obeys Einstein's universal speed limit.
But is it really worth accepting that there are many versions of you in parallel universes just to recover locality?
Don't say many. Zillions and trillions and bazillions and an infinite number, essentially, of yous in all kinds of stupid states. I mean, just idiotic nonsense.
Well, locality isn't the only reason many worlds has become...
And it's happening with every single atomic particle. It's creating new universes. So you're in all kinds of new universes created by all the other particles interacting. And it's an insanely silly theory.
More and more popular.
I also really like many worlds, because Copenhagen never sits right, and when you start telling the story, right, of like what happens at measurement, it's like, well, what is a measurement? It's when you have like this quantum system and there's some other system which is like much larger, and so, you know, but
yeah, you know, like really, you know, like you know, he's a valley girl now.
it almost feels a little bit arbitrary, whereas this argument that every time two quantum particles are interacting, their wave functions are essentially, you know, combining and becoming entangled. That to me feels more consistent.
Yes, I think that's right. What do you think are like the problems with many worlds?
The biggest problem.
Oh, so they're all falling for this. This really is. This is going to be the new bullshit. This silly idea that, well, we can just shovel all the problems under the rug because we can just make the rug infinite and just make all the errors disappear. I mean, it's just a bullshit theory.
Is, I think, people's struggle to deal with sort of the infinity that brings forth.
For sure.
But I don't know that that's necessarily an argument against it. Just because it's hard to imagine doesn't mean it's not what's happening.
Oh, brother. You know. So fuck being simple explanations for anything. You know, just make it as wooey and silly as possible.
If many worlds is right, everything changes.
So every single time a piece of photonic energy interacts with anything else in the universe, a new universe is created. That's their theory. I mean, you can't even think about the density of how insanely insane that is. And how... I just don't even know how... Yeah, no, I'm sorry. It just can't be. It's just too ridiculous.
Conflict between quantum mechanics and relativity vanishes. Physicists have been struggling for decades to unite quantum mechanics with general relativity to build a theory of quantum gravity. And maybe we've been failing because we've been trying to marry relativity to a non-local theory. But if quantum mechanics ultimately turns out to be local, well then Einstein's dream of a local description of reality might not be dead after all.
Oh, so they're talking like this is Einstein's dream of the multiverse. I mean, amazing horse shit. No, that's the opposite of his dream. That's wooey shit. Boy, was that ever a pile of lies. So, all of these people, Porter and some other crap, and Mick Away, and Lifty Roppy, and Sam Plu and all of these fucking pieces of shit that support this pile of crap. The world is so fucking rotten and doomed. These people are not going to fix anything. Writers. Let's see how we have all these people involved in making this pile of steaming shit. So, Methuala Yagabakabricken, Casper Meta blah blah blah, and Derek Miller. So he wrote some of this crap. And we got a producer and director. That's Methuala Yagabakabricken. And what the fuck is this? Editors? I don't know if that's what it says, but yeah, camera operator. So you got a couple of those. Animators. So you got like 6 or 7 of those. Illustrators. So I guess those were the original first drawings, which weren't too bad. Assistant editor. So you have an assistant editor. Researcher. They obviously didn't do their job. Thumbnail. I can't believe they have 3 people working on thumbnails. Production team. A whole bunch of people producing it. And then executive producers. Is it just a silly word? Casper guy again and Derek. But what a pile of crap. So the executive producers versus the regular producers. Oh, I hate this planet. I just hate it. Hate it, hate it, hate it. I just hate this fucking shithole of a planet that you people are allowing to be, you know, you're even allowing it to continue to orbit with these fucking lying shitheads on it. Covered with all this human puke. These horrible, awful, creepy beings. So no comments. That is amazing. So the whole fucking video and nobody commented for like an hour and a half. So yeah, that sucks. But whatever. life on Earth. It looked like it's still playing, so I mean, it didn't say it stopped streaming. Yeah, it says there's 7 people in here. But I guess nobody has anything to say. Nothing. They can't say a fucking useful thing. Not one fucking word. Just some encouragement. Something. They just say absolutely nothing. Shit. Oh, God, you people don't feed me nothing. No help at all. So, anyway. So, I guess I just get the hell out of here. There's no point in hanging around at all. Yep, no point at all. Now, let's see, where's the get the hell out of here button? Alright, there it is. Yeah, fuck you people. Yeah, god damn it.